Hey guys, welcome to the channel. Sit back, relax, and let your curiosity wander through the soft corners of the unknown. Tonight, we're diving into the mysteries science still can't explain. The questions that even the brightest minds have yet to solve. From the uncharted depths of the mind to the silent edges of the cosmos, we'll explore the strange, the beautiful, and the unsettling truths that keep researchers awake at night. So take a deep breath, close your eyes if you need to, and drift with me through 20 scientific enigmas that continue to defy explanation. Consciousness is the oldest mystery science has ever faced, and yet it remains the least understood. What does it mean to be aware? To know that you exist, to think, to feel, to experience yourself as something separate from the world around you? It's something so ordinary that we take it for granted, yet so profound that no microscope, no telescope, no quantum formula has ever explained it. Physicists can measure matter, biologists can study neurons, but no one can quite define where you begin and the rest of the universe ends. For centuries, philosophers and scientists have struggled to pinpoint the source of this inner light. René Descartes called it the soul, the ghost in the machine. Later thinkers tried to reduce it to biology, arguing that consciousness is nothing more than electrical impulses and chemical reactions firing inside the brain. But if that's true, then why does it feel like something? Why does a particular pattern of firing neurons produce emotion, identity, and imagination, while another produces nothing but silence? This simple question, why we feel our own existence, is what some scientists now call the hard problem of consciousness. Neuroscientists have mapped the brain in exquisite detail. They know which regions handle sight, sound, memory, and emotion. They can even trigger dreams and out-of-body sensations by stimulating certain areas. But none of that explains why there is a conscious experience attached to it. You can simulate vision, but you can't recreate the sensation of seeing. You can model a decision, but not the feeling of choosing. Somewhere between neurons firing and thoughts forming, awareness appears, unmeasurable, unquantifiable, and utterly essential. Some scientists believe consciousness arises from emergent complexity, that once a system, like the human brain, reaches a certain level of intricacy, awareness naturally blooms like a spark from friction. Others go further, suggesting that consciousness isn't created by the brain at all, but rather channeled through it. This is known as panpsychism, the idea that consciousness is a fundamental feature of the universe, as inherent as gravity or light. In this view, everything has a trace of awareness, from atoms to animals, and the human mind is simply a more advanced receiver. It's a beautiful, if controversial, idea, one that blurs the boundary between science and spirituality. Thinkers like Roger Penrose and David Chalmers have even proposed that consciousness might emerge from quantum processes inside brain cells, microscopic entanglements beyond classical physics. If true, that would mean our thoughts might be influenced by the same strange rules that govern particles and stars. It suggests that awareness is not merely biological, but cosmic, that the act of being conscious connects us to the deepest workings of reality itself. Still, most neuroscientists resist this leap. They prefer to view the mind as a product of evolution, a survival tool honed to help complex organisms predict danger, communicate, and pass on their genes. Consciousness, in this view, is a kind of evolutionary trick, a self-aware control center that gives us the illusion of free will while our brains handle the machinery underneath. It's not that we think, it's that our brains simulate the feeling of thinking. But if that's true, it raises uncomfortable questions. If consciousness is just an illusion, who is being fooled? And if free will doesn't exist, what does that mean for morality, art, or love? These are questions that science can describe, but not answer. They slip through equations like water through fingers. The human mind is not just a problem to be solved, it's a mystery to be experienced. Consider dreams. Every night, the brain conjures entire worlds out of nothing, landscapes, faces, memories, all while you lie still in the dark. The experience feels real, though you know it isn't. And yet, isn't that what life itself feels like? A vivid illusion held together by memory and sensation, stitched seamlessly by awareness. What separates a waking thought from a dream, other than the certainty that one feels more real? Neuroscience can tell us when dreams occur, but not why they exist in the first place. Some say dreams help organize memories or regulate emotion. Others suggest they're a sandbox where the mind practices survival. But no one knows why the dreamer dreams, or why you can wake up changed by something that wasn't real. The enigma deepens when you realize that not all forms of life seem conscious in the way we are, and yet consciousness may not be uniquely human. Dolphins recognize themselves in mirrors. Octopuses display curiosity and creativity. Even plants respond to stimuli in ways that suggest a kind of rudimentary awareness. So if consciousness exists on a spectrum, where does it begin? Is a newborn baby conscious before it has language? Is an artificial intelligence aware when it starts predicting emotion? And if not, how will we ever know when it crosses that line? Technology has made that question even more urgent. As machines grow more advanced, mimicking speech, empathy, and even creativity, some researchers believe that synthetic consciousness might not be far off. But the issue isn't whether a machine can think. It's whether it can feel. Can a neural network know fear, joy, or loneliness? Can it experience awe or love? Or is it forever condemned to imitation, repeating the shape of awareness without the light inside it? In the end, the mystery of consciousness remains where it began, in the quiet, private world behind your eyes. Science can map your brain, record your heartbeat, and predict your choices before you make them, but it still cannot touch the essence of the you that watches all of it happen. That ghostly observer who wonders, who questions, who dreams. Maybe consciousness isn't something to be solved, but something to be honored, a reminder that the universe not only exists, but knows it exists. That amid stars, atoms, and endless motion, there is something capable of whispering, "I am." If consciousness is the final frontier of science, then it's one that refuses to be mapped. Every attempt to measure it, define it, or isolate it slips away like smoke, visible yet intangible. The more we try to observe it, the more it seems to change, adapting and folding back into itself. It's as if awareness was never meant to be dissected, only experienced. And perhaps that's why the mystery continues, because to understand consciousness, we would need to step outside it, an impossible task for the very thing we're trying to study. Modern neuroscience has made extraordinary progress in understanding the mechanics of the brain, yet the hard problem, the question of why there is something it feels like to be alive, remains unsolved. For instance, researchers can trace which neural circuits light up when we experience joy, pain, or fear, but they can't explain why those electrical patterns come with a feeling. A computer can process data, but it doesn't feel sadness or curiosity while doing so. So why does the human brain, made of the same physical matter, possess an inner world of thoughts, colors, and emotions? What gives rise to this invisible theatre where we watch the movie of our own lives? Some scientists propose that consciousness is not located in any single part of the brain, but is instead a network phenomenon, the product of countless connections firing together in harmony. The brain has roughly 86 billion neurons, each forming thousands of synapses. The sheer density of this network might create feedback loops so complex that awareness simply emerges. It's like a symphony too vast for any single instrument to comprehend. But even this elegant theory only explains how the brain processes information, not why it feels like anything to do so. The mystery persists, deep and patient. Others have turned to quantum physics for answers. The OR theory proposed by Sir Roger Penrose and anesthesiologist Stuart Hameroff suggests that consciousness originates in quantum activity within microtubules, the tiny scaffolding inside our brain cells. They believe that the strange laws of the quantum world, where particles can exist in multiple states at once, may also govern thought. If true, that means consciousness is not bound by biology alone. It's a fundamental property of the universe, woven into reality at its smallest scales. Under this view, awareness doesn't just happen inside the brain. It happens through the brain. The mind becomes less a generator and more a receiver, a lens focusing a universal field of consciousness that permeates everything. This idea resonates with ancient philosophies that long predate modern science. Eastern traditions like Vedanta and Buddhism have suggested for millennia that consciousness is the ground of all being, that reality itself arises from awareness, not the other way around. What we call the universe, in this perspective, is consciousness experiencing itself through infinite forms. Modern science may not embrace this notion openly, but it can't entirely dismiss it either. The deeper physics dives into quantum uncertainty, the more it begins to sound like philosophy. If consciousness is indeed fundamental, that would change everything, from our understanding of the cosmos to our definition of life itself. Imagine a universe not made of dead matter, accidentally creating awareness, but one where awareness was there first, shaping matter into form. Stars, cells, and human beings would all be expressions of the same underlying intelligence, localized ripples in an ocean of thought. It's a poetic image, and perhaps that's why it remains controversial. Science prefers equations to metaphors, but the closer we look at the brain, the harder it becomes to deny that something extraordinary is happening inside every one of us, something no microscope can fully explain. Even near-death experiences challenge conventional thinking. Thousands of people who have been clinically dead, no heartbeat, no brain activity, report vivid awareness, floating outside their bodies, seeing light, feeling peace, or reliving memories in impossible detail. While skeptics attribute this to oxygen loss or brain chemistry, others argue it suggests that consciousness might persist even when the brain shuts down. If that's true, then awareness may not end with death. It may transcend it, existing in ways science cannot yet measure. Artificial intelligence has added another layer to the puzzle. Machines now mimic language, emotion, and creativity, blurring the line between human and algorithm. But are they truly aware, or are they just reflecting our own consciousness back at us? Can a program that writes poetry or paints pictures actually feel what it's creating? Many experts say no, that AI lacks qualia, the subjective inner experience that defines consciousness. Others believe it's only a matter of complexity and time. If awareness is a product of information patterns, then a machine could eventually achieve self-recognition. But if consciousness is something deeper, something cosmic or metaphysical, then no circuit, no matter how advanced, will ever awaken. Somewhere between those two extremes lies a middle path. That consciousness may arise through both biology and something more mysterious. The human brain may not create awareness, but amplify it, like a radio picking up signals from beyond itself. That might explain why meditation, sensory deprivation, or psychedelic substances can dramatically alter perception. They temporarily retune the frequency of the mind, revealing different dimensions of awareness that are normally filtered out. And then there's the strangest question of all. If consciousness is universal, does that mean the universe itself is aware? Cosmologists have long wondered whether the cosmos has an intrinsic intelligence, a capacity to observe itself. After all, humans are made of stardust, and it's through us that the universe becomes self-aware. When you gaze up at the night sky, you are not merely observing creation, you are creation observing itself. For now, science stands humbly before the mystery. We can scan brainwaves, decode thoughts into images, and even predict decisions seconds before we make them. But none of that tells us what it feels like to be alive, to love, to wonder, to dream. Consciousness is not a chemical. It's the canvas upon which everything else appears. The final question may not be, how does the brain create consciousness? But rather, what is the brain within consciousness? So when you close your eyes tonight and drift into sleep, remember that the world you enter, the one of color, sound, memory, and imagination, is not out there somewhere. It's inside you. It's the only universe you'll ever truly know. And while science may one day uncover the mechanics behind awareness, the mystery of it, the simple fact that you can experience anything at all, may remain the most beautiful unanswered question in existence. If consciousness is the greatest mystery of the mind, then dark matter and dark energy are the greatest mysteries of the universe. Together, they make up roughly 95% of everything in existence, and yet we can't see, touch, or directly measure either of them. Everything we know, every star, planet, atom, and molecule, makes up less than 5% of the cosmos. The rest is made of something invisible, untouchable, and, for now, completely unknown. When we look at the night sky, we assume that what we see is the universe, glowing galaxies and swirling clouds of light. But what if that's only the visible tip of a vast, unseen structure? In the 1930s, astronomer Fritz Zwicky made an observation that would change physics forever. While studying the Coma cluster of galaxies, he noticed that the galaxies were moving too fast to be held together by the gravity of their visible matter. Something unseen had to be providing extra mass, an invisible glue binding galaxies in place. Zwicky called it dunkel Materie, or dark matter. For decades, his idea was considered speculative, even absurd, but later discoveries confirmed his suspicion. Astronomers found that galaxies spin in a way that defies the known laws of physics. The outer stars rotate just as fast as those near the center, even though visible matter predicts they shouldn't. It was as if an invisible halo of mass was holding them together. Without that unseen mass, galaxies would simply fly apart. So what is this mysterious substance? Scientists have proposed dozens of theories. One of the most popular is that dark matter consists of WIMPs, weakly interacting massive particles that barely interact with ordinary matter, passing through us and the Earth like ghosts. Another candidate is axions, hypothetical particles so light that trillions could fit in a single cubic centimeter. Others suggest dark matter could be made of primordial black holes, tiny remnants left over from the birth of the universe. But despite billions spent on research and the most sensitive detectors ever built, not a single dark matter particle has been confirmed. Experiments buried deep underground, like the LUX Zeppelin detector in South Dakota or the Xenon-T project in Italy, are designed to capture even the faintest whisper of dark matter interacting with normal atoms. So far, they've found nothing. Each null result deepens the mystery. Perhaps dark matter doesn't behave like particles at all. Perhaps it's something we can't yet imagine. A new force, a new dimension, or a flaw in our understanding of gravity itself. That's where things get stranger. Some physicists argue that maybe dark matter doesn't exist, that what we're seeing is the result of modified gravity, a phenomenon known as MOND, modified Newtonian dynamics. According to this theory, our equations for gravity might break down at cosmic scales, meaning galaxies stay bound not because of invisible matter, but because gravity behaves differently than we think. Yet every time this theory is tested, it struggles to explain the full range of cosmic evidence. Something unseen is still out there, shaping everything, refusing to be known. If dark matter is the universe's hidden skeleton, then dark energy is its restless heartbeat. While dark matter pulls galaxies together, dark energy pushes them apart, an invisible force accelerating the expansion of the universe itself. This discovery came unexpectedly in 1998, when two teams of astronomers studying distant supernovae realized that galaxies weren't just moving away from each other. They were doing so faster and faster over time. The universe wasn't slowing down. It was speeding up. Something unseen was fueling that acceleration, a kind of anti-gravity that pervades the vacuum of space. The simplest explanation comes from Einstein's old equations. In his theory of general relativity, he included a term called the cosmological constant, a kind of energy that fills space uniformly. He later called it his greatest blunder, but decades after his death, that same constant became the best explanation for dark energy, an invisible pressure expanding the universe. Some physicists see dark energy as the natural property of quantum vacuum energy, the background hum of particles flickering in and out of existence. But here's the problem. If we calculate that energy using quantum theory, the result is off by a factor of 10 to the power of 120, the most inaccurate prediction in all of physics. That number is so large, it defies imagination. It's as though the universe is whispering that something fundamental is missing from our understanding of reality, a missing law, a hidden symmetry, or an undiscovered field that connects matter, energy, and space itself. Some propose that dark energy may be the effect of extra dimensions leaking gravity into our universe. Others believe it might signal that our universe is just one bubble in a vast multiverse, each expanding and interacting in ways beyond our perception. What's most haunting is how subtle it all is. We can't feel dark matter, we can't sense dark energy, yet they shape everything, from the birth of galaxies to the fate of the cosmos. Without dark matter, stars wouldn't have formed. Without dark energy, the universe might have already collapsed under its own gravity. These invisible forces are both the scaffolding and the storm of existence, the quiet architects behind the stars we see. And while telescopes grow more powerful each year, from the James Webb Space Telescope peering into the early universe to massive detectors scanning the cosmic microwave background, the answers remain elusive. Every new discovery only deepens the paradox. How can something that makes up nearly all of existence remain completely invisible? How can the very foundation of the universe hide from the tools designed to reveal it? Maybe the truth is that the universe is more like consciousness than we realize, a vast mystery that cannot be fully observed because we are part of it. Just as the mind cannot look directly at itself, perhaps the cosmos cannot reveal its deepest layers to the beings who emerged within it. For now, dark matter and dark energy remain two halves of the same cosmic riddle, one pulling, one pushing, both shaping the destiny of everything. They remind us that what we see is only a fraction of what is real, that the universe, like the mind, hides more than it reveals. To grasp how strange dark matter and dark energy truly are, imagine standing in a vast, empty cathedral. The echoes you hear are not from what's visible, the stone walls, the arches, or the glass windows, but from something that fills the space between them, unseen but powerful. That's what these invisible forces are to the cosmos, the background structure that makes everything possible. The stars, galaxies, and planets are only the decorative carvings on the walls. The real foundation lies in the darkness itself. In the years since their discovery, scientists have tried to describe the relationship between dark matter and dark energy as a kind of cosmic tug-of-war. Dark matter pulls inward, binding galaxies and galaxy clusters with invisible gravity. Dark energy pushes outward, driving the universe to expand faster with every passing second. Between them lies a delicate balance, a dynamic tension that determines whether the cosmos will expand forever, tear itself apart, or one day fall back into silence. One of the most haunting implications of this battle is the fate of the universe. If dark energy continues to accelerate cosmic expansion, distant galaxies will drift away faster than light can reach us. Over billions of years, the night sky will grow emptier and darker until only a few faint stars remain. Astronomers call this the heat-death scenario, a future where all motion ceases, all energy spreads thin, and the universe becomes an endless void of frozen silence. Others suggest a far stranger ending, the Big Rip, in which dark energy's push grows so strong that it eventually tears apart galaxies, solar systems, and even the atoms themselves. But what if dark energy isn't constant? Some cosmologists believe it could evolve over time, changing its strength as the universe ages. This idea is known as quintessence, a kind of dynamic energy field that waxes and wanes like the tides. If true, then the universe might not be doomed to eternal expansion after all. Dark energy could one day reverse its effect, allowing gravity to pull everything back together in a final collapse, the Big Crunch. And out of that collapse, perhaps a new universe could be born, repeating the cycle forever. These aren't just scientific guesses, they're the most serious questions physics faces. What makes them profound is how unseeable they are. Dark matter and dark energy can only be inferred, never directly observed. Their existence is revealed only through their effects, the way galaxies spin, the way light bends as it travels through space, the way cosmic expansion accelerates like an unseen breath. They are the footprints of the invisible, shaping everything, yet remaining beyond our reach. Some researchers suspect that both mysteries might be different aspects of the same unknown phenomenon. In this theory, the universe might not contain two unseen forces, but one, a single cosmic field manifesting as both attraction and repulsion, depending on scale. It's an elegant idea, but impossible to prove with our current technology. To detect such forces directly, we would need instruments far more sensitive than anything on Earth, perhaps built in space, shielded from radiation, and capable of sensing interactions weaker than a whisper. Philosophically, dark matter and dark energy raise a deeper question. How much of reality will humans ever be able to know? Every discovery seems to expand not just our knowledge, but our ignorance. We once believed the universe revolved around us. Then we learned we were orbiting the sun. Then that our galaxy was just one among billions. Now, even those galaxies turn out to be only a fraction of what truly exists. The cosmos keeps humbling us, reminding us that the visible world, the one we touch, see, and measure, is little more than a thin surface over a vast, invisible ocean. There are hints that this mystery may even tie into the nature of time and consciousness itself. Some physicists propose that what we perceive as dark energy might not be an external force at all, but a byproduct of how space-time interacts with itself. If space-time has curvature, motion, and pressure, then expansion could be an illusion created by the geometry of reality, a side effect of how the universe observes itself. It's speculative, yes, but so were black holes once. The search for dark matter and dark energy has become a quiet pilgrimage, scientists building ever more sensitive detectors, like monks tuning their instruments to listen for the faint hum of the divine. Deep under mountains, in tunnels, and inside liquid xenon chambers colder than outer space, they wait. Each faint pulse of light, each particle collision could hold the secret to the unseen universe. And yet, for all our effort, nature remains silent. The universe seems to enjoy keeping its secrets. The irony is that even without understanding these forces, we owe them everything. Without dark matter, galaxies wouldn't exist. Without dark energy, the universe might have never grown large enough for life to form. We are here, thinking, feeling, wondering, because of the balance between two invisible powers that science can't yet explain. The atoms in your body are the debris of stars, and those stars were born from dark matter's invisible grip. The space between your atoms, the silent void holding them together, echoes the same dark energy expanding the cosmos. In a very literal way, the unknown is part of who we are. It's humbling to think that we may never see the answers. Humanity might live and die without ever catching a glimpse of a dark matter particle or understanding the source of cosmic acceleration. But perhaps the point was never to solve it completely. Perhaps the purpose of these mysteries is to remind us that knowledge, like the universe itself, is still expanding. When we look up at the stars, we see light that has traveled for billions of years. But what we don't see, the darkness between those stars, is even more profound. It's the unspoken story of existence, the silent architecture that makes reality possible. And maybe that's what the universe has been trying to tell us all along, that not everything real can be seen, and not everything unseen is empty. Because in the end, it is the unseen that holds the universe together, and the unknown that keeps us searching. In the quiet deserts of northern New Mexico, beneath a sky so clear you can almost see time itself drift by, there is a sound that science can't explain, a low, persistent hum that vibrates through the earth and into the bones of those who hear it. Locals call it the Taos hum, named after the small town where it first gained attention in the early 1990s. It's not loud or sharp, but deep and steady, like the low growl of a distant engine that never fades. Some describe it as maddening, others as hypnotic. But for decades, no one has been able to find its source. The hum is more than folklore. It's been documented, studied, and debated by scientists, engineers, and even government agencies. Roughly 2% of the population claims to hear it. They're called hearers. To them, the sound is constant, following them indoors and outdoors, day and night. It's not just in Taos either. Reports have surfaced from Bristol in England, Windsor in Ontario, Largs in Scotland, and even rural areas of the American Southwest. Each location describes the same phenomenon, a low-frequency hum between 30 and 80 Hz, barely detectable by standard instruments, yet strong enough to drive some listeners to insomnia and despair. When scientists first investigated the Taos hum in 1993, they brought equipment capable of detecting seismic vibrations, electromagnetic waves, and low-frequency sound. The team included experts from Los Alamos National Laboratory, the University of New Mexico, and even the Air Force. But after weeks of testing, the results were inconclusive. They found no consistent frequency, no common environmental source, and no external signal that matched what people were describing. The sound existed only in the minds, or perhaps the bodies, of those who heard it. That discovery only deepened the mystery. Was the Taos hum a physical vibration, an auditory illusion, or something in between? Some suspected hidden industrial sources, gas pipelines, cell towers, high-voltage transformers, or oceanic resonance traveling through the Earth's crust. Others blamed low-frequency electromagnetic radiation, like that emitted by military radar or submarine communication systems. But even after testing these possibilities, the hum persisted in areas far from technology, deep in the wilderness, where no machinery existed. Psychologists proposed that the sound might be a product of auditory processing, a kind of internal feedback loop, where the brain amplifies its own noise until it becomes perceptible. Human ears aren't silent. They constantly produce faint vibrations. For most of us, the brain filters them out. But for a small percentage, it might not, meaning the Taos hum could actually be a byproduct of the brain listening to itself. Yet this theory can't explain why the hum is reported by multiple people in the same location, often describing the exact same pitch and intensity. Even more puzzling are the physiological effects. Some hearers report headaches, pressure in the ears, nausea, and anxiety. Others say they feel the vibration more than they hear it, a subtle trembling in their chest or skull. In one case, a Taos resident recorded herself reacting to the hum's rhythm, even though her audio equipment picked up nothing. "It's like the earth is purring," she said. "You don't just hear it, you feel it inside your bones." Theories became wilder as the mystery grew. Some claimed the hum was a byproduct of natural resonance within the Earth, a global acoustic vibration known as the Schumann resonance, which oscillates at around 7.83 Hz and is generated by lightning strikes. Others speculated it might be linked to tectonic plate movement, a sort of pre-seismic frequency emitted by the planet itself. A few even wondered if the hum might be evidence of geoacoustic communication, signals traveling through the planet's magnetic field that certain people are sensitive enough to detect. Then came the psychological theories. Could the hum be a modern manifestation of something ancient, a shared human sensitivity to background frequencies we've evolved to ignore? Some anthropologists noted that ancient cultures described earth tones or cosmic music heard during meditation or isolation. Perhaps the Taos hum isn't new at all, but a rediscovery of something primal, the sound of the Earth's own electrical heartbeat. But there's also a more personal layer to the story. Many who hear the hum report feeling isolated, doubted, or even dismissed. Some have moved away from Taos altogether, only to find the hum following them wherever they go. To them, the sound isn't a curiosity, it's a haunting. And while science seeks data, they live with experience. "You start to question your sanity," said one resident. "You wonder if it's real or if you're losing your mind." But then someone else looks at you with the same tired eyes and says, "You hear it too." And you know it's not just you. That shared acknowledgement is perhaps the most unsettling part. The hum connects strangers across continents, linking them through a phenomenon that transcends explanation. Scientists continue to monitor low-frequency anomalies around the world, and while new technologies have ruled out some causes, like industrial noise or electrical interference, the core mystery remains intact. Every explanation falls just short, as if the truth hides in a frequency just beyond what we're capable of detecting. Whatever its origin, the Tao's hum reminds us that the world hums with forces we still don't understand. It hums in the quiet spaces between scientific certainty and sensory perception, between the measurable and the felt. Whether it's an internal resonance, an environmental anomaly, or a phenomenon science has yet to name, it forces us to confront an uncomfortable idea: that the boundary between external reality and human perception is thinner than we think. Maybe the hum isn't just in the air or the earth. Maybe it's a vibration between worlds, a faint reminder that even silence has a sound, and even the quietest mysteries can shake the human soul. The mystery of the Taos. Hum did not end in New Mexico. It spread, not like an infection, but like a resonance, a low vibration that seemed to travel from one continent to another, quietly linking distant places through a sound no one could prove existed. By the late 1990s, reports were emerging from every corner of the world. People in Bristol, England, claimed they could hear it rumbling under their homes. Residents of Windsor, Canada, described sleepless nights filled with an invisible pulse. In Largs, Scotland, entire communities demanded government investigations. No matter where the reports came from, the description was always the same: a deep, mechanical hum that could be felt as much as heard, often strongest at night, and impossible to locate. Scientists began calling it a global low-frequency phenomenon, but that only gave it a new name, not an explanation. The British government commissioned several acoustic studies in the early 2000s to analyse the Bristol hum. Sound engineers recorded low-frequency waves coming from industrial sources like factories and diesel ships. However, even after controlling for these noises, many hearers said the hum persisted. It wasn't just a sound, it was an experience. And it didn't behave like any conventional vibration. It could pass through walls, remain steady through storms, and vanish without warning. In Windsor, the hum was traced, at least partially, to the Zug Island steel mills across the border in Michigan. When the factories shut down in 2020, residents reported that the hum faded for the first time in decades. But even then, not everyone agreed it was gone. Some still heard it. Some never did. The question remained: if it was only industrial noise, why could only a few people hear it? Why didn't microphones capture it with clarity? And why did similar reports emerge in remote locations where there were no factories at all? One of the most intriguing discoveries came from a series of field recordings made in New Zealand and Western Australia, where local communities described a sky hum that seemed to move across the horizon like a living wave. In 2006, a geophysicist named David Deming proposed that the hum might be caused by very low-frequency VLF electromagnetic waves naturally produced by lightning and amplified through the ionosphere. These waves can travel thousands of miles and may vibrate at frequencies low enough to affect the inner ear. But again, if the phenomenon was global, why could so few detect it consciously? Was it a physical effect or a perceptual one? This line of questioning drew scientists into one of the strangest corners of auditory science: infrasound. Humans can hear frequencies roughly between 20 Hz and 20,000 Hz. Infrasound falls below that threshold. It can travel through the ground, through air, and even through buildings, often generated by earthquakes, volcanic activity, or wind passing through mountain ranges. In rare cases, exposure to infrasound has been shown to cause dizziness, anxiety, and the sensation of sound without hearing it. Some researchers speculate that the Taos hum and its global cousins could be natural forms of infrasound amplified by geography, a kind of planetary whisper that only the most sensitive can perceive. But infrasound doesn't explain everything. In several cases, hearers have recorded unusual electromagnetic fluctuations corresponding with the hum. Others report physical pressure in their skull or chest, as though the vibration is internal rather than external. These effects are difficult to fake and impossible to replicate consistently. When controlled experiments were conducted, isolating volunteers in soundproof chambers, some hearers claimed the hum followed them into total silence. That suggested the source wasn't out there in the world. It was inside them. This realization blurred the line between physics and psychology. The human auditory system is incredibly complex, with the brain filtering out thousands of sensory inputs every second. Occasionally, that system misfires, causing auditory hallucinations or the perception of phantom sounds, known as tinnitus. However, the Taos hum is distinct from tinnitus because it has a clear frequency and rhythm that multiple people can agree on. Some scientists believe the hum may arise from resonance coupling, when the body's tissues or bones naturally vibrate in harmony with low-frequency waves that the ears can't register. In other words, people may not be hearing the hum, they may be feeling it, with their own bodies acting as antennas. Still, the mystery continues to resist categorization. Every explanation, geological, industrial, psychological, biological, accounts for some aspects, but not all. And in the spaces between these theories, folklore begins to bloom. Some claim the hum is part of a government experiment, a byproduct of hidden communications technology or military sonar bouncing off the atmosphere. Others turn to more metaphysical answers, that it's the sound of the Earth itself, a planetary consciousness vibrating through matter, reminding humanity that we're part of something much larger than ourselves. Cultural interpretations of the hum reveal how people turn the unknown into meaning. In some indigenous traditions, low-frequency vibrations are seen as messages from the Earth, a reminder of balance and interconnectedness. In others, the hum is viewed as a frequency shift, a sign of the planet awakening to a higher vibration. Whether symbolic or scientific, these beliefs suggest that the hum touches something deeply human. Our instinct to listen for patterns in the silence, to find purpose in the noise. Over the years, hearers have formed online communities to share experiences and track data. Some have mapped global hotspots, discovering curious correlations between human reports and tectonic boundaries, magnetic anomalies, and oceanic resonance zones. Others treat it as a personal journey, a strange, shared affliction that binds them across time zones. Many have learned to live with it, describing a kind of acceptance. "It never stops," one man from Bristol wrote, "but I've stopped fighting it. Now I think of it as the world breathing." That sentiment captures the quiet beauty of this mystery. The hum may drive some people to sleeplessness and frustration, but it also inspires wonder. It reminds us that even in the age of satellites and algorithms, the world still hums with secrets beyond comprehension. For some, it's torment. For others, it's proof that life, and the planet itself, is more alive than we imagine. To this day, no experiment, no recording, and no mathematical model has been able to solve it. The Taos hum remains what it has always been. A sound without a source, a question without an answer, and a reminder that science, for all its power, still listens in the dark. Maybe the hum isn't something we're supposed to explain. Maybe it's something we're supposed to hear, to feel, and in that quiet vibration, remember that mystery itself has a sound. 'Tis one of the strangest sensations known to the human mind. A fleeting, almost electric moment when time folds in on itself, and you swear you've lived this exact instant before. You walk into a room, hear someone speak, or turn your head toward a view, and suddenly your brain whispers, "I've been here already." That eerie flicker of familiarity, as if your life is replaying itself for a heartbeat, is called déjà vu, and science, despite all its advances, still can't fully explain what it is or why it happens. The term déjà vu comes from French, meaning already seen. It was first described in the 19th century by a philosopher named Émile Boirac, who recognized the feeling as both deeply personal and universally mysterious. Since then, almost everyone has experienced it at least once, though no two descriptions are identical. Some feel a strange comfort, like returning home to a memory long forgotten. Others feel disoriented, unsettled, as if they've just glimpsed a glitch in reality. What's most fascinating is that déjà vu doesn't come with a clear memory attached. You know you've experienced this before, but you can't say when or where. It's recognition without recall, a memory without a source. For decades, psychologists and neuroscientists have tried to unravel the mechanism behind this illusion. The most widely accepted theory today is that déjà vu is the result of a misfire in the brain's memory systems, particularly in the temporal lobe and hippocampus, the regions responsible for processing and storing memories. Normally, when you encounter something new, your brain quickly checks it against past experiences. If there's no match, it labels it new. But in déjà vu, this process seems to slip, and the brain mistakenly flags the moment as familiar, even though it's not. It's as if two circuits, one for recognition and one for context, fire out of sync for a split second, creating a false overlap between past and present. To visualize it, imagine your brain as a massive library where every experience is a book. Normally, when something happens, your mind scans the shelves and files it under new arrivals. But in déjà vu, the librarian accidentally places it in the previously read section. You open the book, expecting to find familiar pages, only to realize the words have changed. The sensation is both uncanny and captivating, a neurological hiccup that reveals just how fragile our sense of time and memory really is. However, not all theories rely on memory glitches. Some researchers believe déjà vu may result from neural delay, when information travels along different pathways in the brain and arrives milliseconds apart. The first signal gives a subtle feeling of recognition before the second provides full perception. By the time the brain synchronizes, it interprets the lag as a repetition. This would explain why déjà vu happens most often during fatigue or distraction, when cognitive timing is more likely to falter. Others propose that déjà vu is tied to spatial familiarity, the recognition of geometric patterns or layouts rather than events. Your brain might unconsciously recognize the shape of a room, the symmetry of light, or the angle of an object that resembles something from your past. Even if you can't consciously recall the memory, your brain reacts as though you've seen it before. This theory is supported by experiments where participants were shown computer-generated scenes. Some scenes triggered déjà vu simply because their structures resembled places the participants had seen earlier, even if they didn't consciously notice it. Still, the phenomenon refuses to stay neatly boxed within neuroscience. For centuries, déjà vu has fascinated philosophers, writers, and spiritual thinkers alike. Some ancient traditions view it as evidence of reincarnation. echoes from past lives surfacing briefly in the present. Others see it as proof of parallel universes, where countless versions of reality coexist, and déjà vu occurs when those timelines momentarily align. While such ideas remain speculative, they speak to something science has yet to explain: why déjà vu feels so much deeper than a mere glitch. There's a sense of meaning in it, a whisper that something beyond logic is at play. Interestingly, déjà vu appears more common among people who experience high levels of dream recall or creative imagination. Some studies suggest it may occur when waking reality resembles the emotional tone of a dream, creating a subtle resonance between conscious and subconscious memory. Others link it to temporal lobe epilepsy, where electrical disturbances in the brain create brief, vivid sensations of familiarity before a seizure. But most déjà vu experiences occur in perfectly healthy brains, leaving the question of why it happens at all open-ended. What makes déjà vu so haunting is not the feeling itself, but its implications. It challenges our perception of time as linear. For that brief moment, the present feels recycled, as if time itself hiccuped. Neuroscientists call it temporal lobe misfiring, but even they admit it's more than a technical glitch. It's a window into how the brain constructs reality. We don't perceive time directly. We assemble it from fragments of experience. Déjà vu might be the moment when that construction falters and we catch a glimpse of how fragile it really is. Then there's the emotional undertone, that quiet awe many people feel during déjà vu. It's as if some ancient part of the brain recognizes the strangeness of existence itself. For a fraction of a second, we're aware not only of the moment, but of our awareness of it. Consciousness doubles back on itself, like a mirror reflecting a mirror. Perhaps that's why the feeling fades so quickly, because our brains can't sustain that recursive loop for long. It's too heavy, too infinite, too strange. In one famous study, scientists attempted to artificially trigger déjà vu using virtual reality. They designed computer simulations of cities and subtly repeated certain visual patterns across different locations. Participants reported déjà vu even when they were told they hadn't seen the scenes before. The researchers concluded that déjà vu may be the brain's way of checking its memory for errors, a kind of self-correcting process that occasionally backfires. It's the mind's version of déjà vu, debugging reality in real time. Still, there's a certain poetry to the idea that our brains, in their constant effort to organize chaos, sometimes trip over their own brilliance. Déjà vu reminds us that memory and perception are not absolute truths, but living processes, fallible, elastic, and deeply human. So the next time that strange wave of familiarity washes over you, don't rush to dismiss it. Instead, pause and notice the feeling. That quiet recognition might just be your brain revealing its secrets, showing you for the briefest instant that reality is a story it's still learning how to tell. If déjà vu is the mind's whisper that we've lived a moment before, then its true mystery lies in what that whisper represents. Is it an illusion of memory, or a hint that our understanding of time is incomplete? In that instant of uncanny familiarity, when the present folds into something that feels ancient, we stand at the threshold of one of science's most elusive frontiers, the nature of consciousness itself. To understand déjà vu's depth, we must look beyond the clinical explanations and consider its broader implications. The brain's temporal lobe, long associated with memory, emotion, and perception, acts like a bridge between experience and recollection. When it falters, our sense of linear time blurs. Experiments with patients who have temporal lobe epilepsy have revealed that déjà vu can sometimes occur seconds before a seizure, as if the brain is replaying its own activity. This has led researchers to theorize that déjà vu may be a miniature neurological echo, where neurons briefly fire in the same pattern twice, convincing us we've experienced the moment before. But what's fascinating is how déjà vu often carries an emotional charge. It's not just a logical glitch, it feels profound. There's a texture to it, a gravity that words struggle to describe. You don't just think, "This feels familiar." You feel it in your chest, like a resonance. This depth suggests that déjà vu is not merely cognitive, but existential. The mind encountering its own reflection in time. Some scientists have taken this a step further. They propose that déjà vu might be connected to the predictive coding model of the brain. In this view, the mind is constantly predicting the future a few milliseconds ahead, an evolutionary mechanism that helps us react faster to danger. When those predictions perfectly align with reality, the brain experiences a flash of hyper-recognition, an internal echo that feels like memory. Déjà vu, then, might be our brain momentarily catching up with its own forecast, experiencing the convergence of what will happen and what is happening, as if it already occurred. This could explain why déjà vu is so brief. It's not a prolonged experience, but a flicker, the instant our predictive and perceptual timelines overlap. When they synchronize too perfectly, the brain mistakes prediction for remembrance. Reality, for a moment, loops back on itself. Yet the allure of déjà vu extends far beyond the laboratory. Throughout history, people have interpreted the sensation as something deeply mystical. Ancient Hindu texts describe samadhi, a meditative state in which time and memory dissolve, allowing one to glimpse the eternal present. In that state, every moment feels like a return, every experience a repetition of something cosmic. Déjà vu echoes this idea, the notion that perhaps time isn't linear but cyclical, and our lives unfold in infinite spirals, occasionally brushing against familiar patterns. Philosophers, too, have wrestled with the phenomenon. Friedrich Nietzsche's concept of eternal recurrence imagined that every event in the universe repeats endlessly, down to the smallest detail. When we experience déjà vu, perhaps we're feeling that repetition, an echo from a past life, or even a previous cycle of the cosmos. While science has no evidence for such metaphysics, it's easy to see why people gravitate toward that interpretation. Déjà vu feels timeless. It feels like touching the fabric of something infinite. Modern physics offers another eerily fitting angle. According to theories in quantum mechanics and multiverse cosmology, our universe may not be the only one. Infinite variations of reality could coexist, each differing by the smallest details. If consciousness is somehow linked across these versions, like radio frequencies tuned to slightly different channels, déjà vu could be the moment when one version of you aligns with another. The overlap would feel like memory, even though it's a glimpse across dimensions. It sounds like science fiction, but the math doesn't rule it out. Of course, not all scientists agree with such interpretations. Many caution that déjà vu should be understood as a memory anomaly, not a metaphysical event. Yet even this conservative view doesn't diminish its beauty. Because what déjà vu really exposes is how our minds construct reality, moment by moment, from fragments of sensory data and stored experience. The feeling of nowness, of living in the present, is an illusion carefully maintained by the brain. Déjà vu is what happens when that illusion flickers, when we momentarily catch the machinery of consciousness in the act. What's even stranger is that déjà vu isn't confined to waking life. Many people report experiencing it in dreams, moments when they dream of déjà vu itself, creating layers of recognition that blur the line between sleep and waking memory. Some scientists think this overlap reveals how the brain's memory consolidation process, which organizes experiences during sleep, occasionally creates false familiarity when similar sensory patterns reappear later in waking life. The mind, in essence, confuses dream memory with lived experience. There's something deeply human about this. Déjà vu reveals not just the quirks of brain function, but the yearning for meaning hidden within every flicker of recognition. We crave patterns, even in randomness. We search for stories, even in fragments. And when the mind momentarily loops, we sense that maybe time isn't as straight as we thought, that maybe, in some subtle way, every moment is connected. Perhaps déjà vu exists to remind us of that we are creatures of repetition, shaped by cycles of memory, emotion, and experience. Every thought, every habit, every heartbeat is a repetition of something that came before. Déjà vu is just the moment when that truth becomes visible, when the illusion of linear time briefly cracks to reveal the rhythm underneath. When it passes, we're left in silence, a little dazed, a little awed. The world feels slightly altered, as if we've walked through a thin veil between what is and what has been. And though the sensation fades, its mystery lingers. Because deep down, déjà vu is a reminder of something we rarely think about, that memory, time, and consciousness are not separate things. They are reflections of one another, endlessly looping in the quiet theater of the mind. So the next time that flicker of familiarity strikes, when the air shifts and the moment feels doubled, don't dismiss it as a trick of the brain. Think of it as a reminder from the universe that you've been here before, in some form, in some way. Maybe not in this life, maybe not in this world, but somewhere, some version of you remembers. In the summer of 1997, a strange and powerful sound echoed through the depths of the Pacific Ocean, a sound so loud that it was picked up by hydrophones over 3,000 miles apart. It rose in pitch, low and organic, like something alive, pulsing beneath the surface of the sea. Researchers at the U.S. National Oceanic and Atmospheric Administration, NOAA, named it the bloop. At first, they assumed it was a mechanical anomaly, or perhaps the echo of shifting ice. But when they analyzed its acoustic signature, their jaws dropped. The sound matched the profile of a living creature, only thousands of times louder than any wail known to science. The ocean has always been a place of mystery, vast, dark, and largely unexplored. More than 80% of its depths remain unmapped, meaning that most of what lives there is still a secret. But the bloop was different. It wasn't just a mystery, it was an event. Detected by the Equatorial Pacific Ocean Autonomous Hydrophone Array, a system originally designed to track submarines during the Cold War, the bloop was a sound unlike anything ever recorded. Lasting about 1 minute, it swept upward in frequency, suggesting a natural biological source. Yet the sheer intensity of it was beyond anything a biological organism could produce, at least anything we know of. To put it in perspective, the loudest whale songs ever recorded, those of the blue whale, the largest animal on Earth, reach around 180 decibels and can travel hundreds of miles underwater. The bloop, by contrast, would have had to originate from something many times larger. To produce that level of sound, whatever made it would have to be several times the size of a blue whale, possibly a creature spanning hundreds of meters in length. That's when the theories began. Some scientists proposed that the bloop was caused by ice quakes, massive chunks of ice breaking away from Antarctic glaciers and producing seismic-like vibrations through the ocean. These icequakes can indeed generate sounds similar to marine animals, but on a much larger scale. This explanation eventually became NOAA's official position, especially after they recorded other bloop-like sounds near Antarctica that matched known ice movements. But skeptics weren't convinced, because there was something about the bloop that didn't fit. The original sound wasn't random. It had the organic texture of a biological call, rising and falling in a pattern that mirrored the vocalizations of marine mammals. When slowed down, it even resembled the calls of whales or deep-sea fish, only impossibly loud. And the ocean, with its vast trenches and unexplored caverns, has always been fertile ground for speculation. Could the bloop have been the cry of an unknown leviathan? A remnant of some prehistoric species, or even an undiscovered apex predator of the deep? Some oceanographers, speaking off the record, admitted that the sound structure didn't fully match any known ice activity. Others noted that if it were ice, we would expect to detect similar signals across the globe. But the bloop's unique signature appeared only once. Then came the cultural wave. As the mystery spread online in the early 2000s, the bloop took on a life of its own. Cryptid enthusiasts connected it to stories of sea monsters and ancient myths, from the Norse kraken to the Polynesian taniwha. Even author H.P. Lovecraft's fictional creature Cthulhu found its way into the conversation, since the sound was detected near a location Lovecraft had described as the creature's supposed resting place. 47 degrees 9 minutes south, 126 degrees 43 minutes west, somewhere deep in the South Pacific. The coincidence, of course, only fueled the legend. But for scientists, the fascination wasn't about monsters, it was about what the bloop represented, a rare reminder that even in the age of satellites and sonar, the Earth still keeps secrets. The ocean is the most alien environment on our planet, with pressures and temperatures so extreme that light itself vanishes just a few hundred meters down. Yet life thrives there. Creatures that glow in the dark, survive without sunlight, and endure forces that would crush steel. In such a place, is it really impossible that something vast and unknown could exist? The biology of sound in the ocean adds another layer of intrigue. Underwater, sound travels nearly 5 times faster than in air, allowing it to carry incredible distances. Many marine animals, from whales to squid to fish, rely on complex sound communication systems. The deeper you go, the more sound becomes the language of survival. Some species even produce infrasonic or ultrasonic vibrations beyond human hearing. So, if a creature evolved to dominate this hidden realm, its vocalizations could be immense, possibly even approaching the magnitude of the bloop. Still, the scientific community prefers caution. NOAA's conclusion that the bloop was ice-related remains the official answer. Yet they admit that the full details of the sound's structure, intensity, and location are still being studied. Icequakes are indeed capable of generating similar signals, but the bloop's unusual acoustic rise, the way it swept upward in frequency like a biological sound, remains unusual. Interestingly, the bloop wasn't the only unexplained sound detected by NOAA. Around the same period, researchers catalogued other mysterious signals: Julia, upsweep, train, and slowdown. Each had its own unique signature, some lasting minutes, others hours. While a few were eventually traced to natural causes, others remain ambiguous. Together, they suggest that the ocean is filled with voices we've barely begun to understand, a vast, humming archive of the planet's hidden life. Perhaps that's the real revelation. The bloop isn't frightening because it suggests monsters. It's frightening because it reminds us how little we know. Beneath the waves, beyond the reach of light, there are entire ecosystems we've never seen, possibly even intelligent life forms that communicate in ways beyond our comprehension. The deep ocean is not silent, it's alive with whispers. For now, the bloop sits at the edge of science and myth, a data point on a chart that refuses to reveal its source. But in a way, that's fitting. Every mystery begins with a sound we don't yet understand. Whether it came from shifting ice or something alive, the bloop remains a humbling reminder that our planet, even now, is not fully mapped. It's not conquered. It's still wild. And somewhere in the abyss, that low, rising pulse may still echo, a call from the deep that science has yet to answer. After the first recording of the bloop in 1997, the world of oceanography was never quite the same. What began as a single unexplained sound soon became a symbol of just how much of Earth's final frontier remains undiscovered. The more scientists tried to study it, the more questions emerged, not just about the source of the sound, but about the deep ocean itself, a realm more alien than any planet we've yet explored. The deep sea is a world of silence and crushing pressure, where sunlight never reaches and temperatures hover near freezing. Yet in that darkness, life thrives, bizarre, bioluminescent, and often beyond imagination. When NOAA's Pacific Marine Environmental Laboratory analyzed the bloop, they found its source to be somewhere near 50 degrees south, 100 degrees west, a remote point in the southern Pacific, far from any major human activity. That isolation was part of what made the sound so unsettling. There were no ships nearby, no drilling operations, and no underwater volcanoes in the immediate region. Just the unbroken expanse of the abyss. For years, researchers monitored the area, hoping for a repeat. While they detected other curious sounds, known by names like whistle, train, upsweep and slow down, none matched the bloop's unique pattern. Each of these anomalies sparked its own theories. Upsweep, recorded since 1991, consists of a constant series of tonal sounds in the Pacific, still unexplained. Slow down, another low-frequency noise detected in 1997, seemed to fade gradually, as if something massive was decelerating underwater. And then there was Julia, a sound so eerie that some scientists compared it to a long, drawn-out wail echoing beneath the ice. The bloop stood apart because of its apparent biological signature. When the recording was sped up, the waveform bore a striking resemblance to marine animal vocalizations. It didn't sound like cracking ice or seismic activity. It sounded alive. Even NOAA researchers admitted this privately, though they maintained that icequakes were the most plausible explanation. But for those who've spent their lives studying the ocean, plausible isn't always satisfying. In 2012, NOAA officially stated that the bloop's characteristics matched the sound of ice carving off the Antarctic shelf. Yet that answer, while convenient, felt incomplete to many. The ocean is full of anomalies, and each discovery often raises more mysteries than it solves. One of the strongest counter-arguments to the icequake theory comes from ocean acoustics itself. Icequakes produce a sharp, transient sound, a short burst, while the bloop exhibited a long, sweeping frequency range that rose over time, much like the communication call of a living creature. The oceanographers who analyzed the original waveform noted that its rise in pitch was almost too smooth to be purely geophysical. Natural processes like ice cracking typically create chaotic waveforms, not structured patterns. Adding to the enigma, NOAA's hydrophones weren't the only ones to capture mysterious signals. Military sonar arrays, remnants of the Cold War's SOS-US system designed to track submarines, had occasionally picked up similar deep-frequency sounds, but most were classified. When fragments of those recordings leaked, they hinted at underwater signals of unknown origin, moving across the ocean in unpredictable patterns. Whether they were mechanical, geological, or biological remains unknown. As the fascination around the bloop spread, researchers began to look at deep-sea ecosystems differently. The event renewed interest in hadal zone biology, the study of life in the deepest parts of the ocean, more than 6,000 meters below the surface. There, researchers discovered giant amphipods, transparent sea cucumbers, and snailfish capable of surviving pressures 1,000 times greater than those at sea level. If such fragile-looking creatures could adapt to these extreme environments, who's to say something enormous and elusive couldn't have evolved there too? This idea isn't pure fantasy. Throughout the 20th century, ocean exploration repeatedly revealed species once thought extinct or mythical. The coelacanth, a prehistoric fish believed to have vanished 65 million years ago, was found alive off the coast of South Africa in 1938. The giant squid, once a sailor's legend, was finally filmed in its natural habitat in 2012. A ghostly creature longer than a city bus, gliding silently through black water. Each rediscovery pushes the boundaries of what's possible and keeps the dream of unknown leviathans alive. The ocean also distorts sound in ways that challenge human intuition. Low-frequency noises can travel for thousands of miles underwater due to something called the SOFAR channel, a layer of the ocean where temperature and pressure combine to create an acoustic highway. A single sound in this zone can bounce around the planet, arriving at detectors continents away. That's why the bloop was so widely heard. But it also means that pinpointing its exact source is nearly impossible. What we interpret as a single location might, in fact, be a resonance, the echo of an event thousands of miles distant. Even if the bloop was caused by ice, it remains a marvel of natural acoustics, proof of how dynamic and alive our planet truly is. Glaciers, in their slow collapse, can sing like whales. Underwater volcanoes rumble like organs. The planet breathes through its oceans, each sound a vibration in Earth's endless rhythm. Yet there's something poetic in the idea that the mystery persists. In an age of data and surveillance, when satellites map even the shadows of Mars, it's humbling to know there are still sounds on our own planet that no one can explain. Perhaps that's why the bloop resonates so deeply, because it speaks to something primal in us, a reminder that the unknown isn't gone. It's just hidden beneath the waves. To this day, NOAA's archives still hold the original waveform, a faint yet powerful sound stretching through the ocean like the heartbeat of something vast and unseen. And while scientists continue to record, monitor and theorize, the allure of the bloop endures. Was it the voice of the Earth? A massive ice shelf collapsing into the sea? Was it the song of an undiscovered creature, one that rises only once in a millennium? Or was it something else entirely? A sound from the deep meant not to be explained, but simply heard. Until we dive far enough to find out, the bloop will remain exactly what it's always been. An echo from the abyss, calling us to listen closer to the mysteries that lie beneath. Hidden in the archives of Yale University's Beinecke Rare Book Library is a book so mysterious that it has baffled scholars, cryptographers, and linguists for over a century. It's called the Voynich manuscript, and it might be the most perplexing document ever discovered. Written in an unknown language, illustrated with strange plants, celestial diagrams, and surreal human figures, The manuscript reads like a message from another world, one that no one can understand. For over 600 years, it has resisted every attempt to decode its meaning, leaving experts to wonder whether it's a cipher, an elaborate hoax, or something even stranger. The story begins in 1912, when a Polish antiquarian named Wilfrid Voynich purchased a collection of old manuscripts from a Jesuit college near Rome. Among them was a small, leather-bound volume, roughly the size of a modern notebook. Its pages were filled with looping, graceful handwriting in an unknown script, no Latin, no Greek, no Hebrew. The letters seemed consistent and deliberate, as if part of a real language, but unlike anything known to linguistics. Interspersed among the text were hundreds of vivid illustrations, women bathing in strange green pools, stars connected by delicate lines, plants that don't exist on Earth, and circular diagrams that seem to represent both astronomy and biology. Voynich immediately knew he had found something extraordinary. He sent copies of the text to some of the best codebreakers and language experts in the world, including those who had worked on military ciphers during World War I. None could decipher even a single word. The language, now known as Voynichese, obeyed statistical patterns like natural speech, suggesting it wasn't gibberish. Words repeated with natural frequency, and sentence structures seemed organized. But every attempt to match it to a known language or code system failed. The manuscript's origins are just as puzzling as its content. Carbon dating has placed the vellum on which it was written around the early 1400s during the Italian Renaissance. But no one knows who wrote it or why. The earliest known owner was Georg Baresch, a 17th century alchemist from Prague, who referred to it as the Sphinx of literature. It later passed through the hands of the Holy Roman Emperor Rudolf II, who was said to have paid the equivalent of thousands of dollars for it, believing it to be the work of Roger Bacon, the medieval English philosopher who dabbled in early scientific experimentation. That claim, however, has never been proven. In the centuries since, the manuscript has invited more theories than perhaps any other historical mystery. Some believe it's a pharmaceutical compendium, a kind of medieval medical text written in a lost or invented language. Others think it might be an encrypted scientific notebook, its illustrations corresponding to real but hidden knowledge. The plants could represent herbal compounds. The bathing women might symbolize human anatomy or biological processes. And the circular diagrams could map the stars or the flow of energy through the human body. But even these interpretations are speculative. No one knows what the text actually says. Then there's the possibility that the entire book is a hoax, an elaborate forgery created to fool an emperor or a wealthy collector. If true, it would be one of history's most successful pranks, maintaining its illusion for over 6 centuries. But if it were a hoax, who could have created it? The handwriting is consistent across more than 240 pages, with linguistic structure too complex to have been invented randomly. To sustain that level of detail, someone would have needed an almost superhuman grasp of language construction, centuries before modern linguistics even existed. In the modern era, cryptographers from the FBI, the NSA, and top universities have all tried to crack the code using advanced algorithms and pattern analysis. Artificial intelligence models have identified possible linguistic families, including Hebrew, Nahuatl, and even Old Turkish, but no translation makes sense across all pages. Every computer-generated solution eventually breaks down, leaving researchers back where they started, staring at symbols that refuse to yield meaning. Even the illustrations complicate things further. The plants look almost real, yet none match any known species. Some have been interpreted as hybrids, combining traits from different flora found on separate continents, an impossible feat for a 15th century author. The astronomical drawings feature stars, moons, and constellations, but not in any recognizable arrangement. There are also strange fold-out pages, including one depicting 9 interconnected circles that resemble both biological cells and planetary orbits, as if the author saw no difference between the microscopic and the cosmic. One of the most debated sections features groups of naked women immersed in greenish fluid connected by elaborate plumbing systems. Some interpret this as alchemical symbolism representing purification or transformation. Others suggest it might be an early attempt at biological mapping, perhaps illustrating the lymphatic or reproductive systems. Still others think it's something more metaphorical, a visual expression of rebirth, energy, or cosmic cycles. But since the text remains unreadable, all interpretations remain speculation. Even stranger are the stylistic clues that defy logic. The manuscript's writing speed and consistency suggest it was composed quickly, as if the author fluently spoke the language they invented. This raises an unsettling possibility. What if it wasn't meant to be deciphered at all? What if the author wrote for themselves, in a private tongue that died with them, never intended for another mind to decode? Psychologists have even suggested that the Voynich manuscript could be an example of glossolalia, or automatic writing, where the author enters a trance-like state and produces structured but meaningless text. But this doesn't explain the manuscript's precise grammar and internal consistency. Glossolalia is chaotic. Voynichese is methodical. No matter how much science advances, the manuscript resists every breakthrough. For over a century, it has existed in a strange space between logic and imagination, too structured to be nonsense, too alien to be rational. And perhaps that's what makes it so captivating. It forces us to confront the limits of human understanding, because sometimes the unknown isn't a puzzle to be solved. It's a mirror, one that reflects our endless desire to find order in mystery, meaning in madness, and language in silence. The deeper you go into the Voynich manuscript, the more it feels like a labyrinth without walls, a puzzle that changes shape every time you think you're close to solving it. For over 100 years, it has pulled in the brightest minds from every corner of science, cryptography, and art, only to send them back out again, empty-handed. Each decade brings new technology, new theories, and new promises of a breakthrough. Yet the manuscript always seems one step ahead, as if it were written to remain forever unread. In the digital age, the Voynich mystery only deepened. With the rise of artificial intelligence and machine learning, researchers hoped that algorithms might uncover linguistic patterns invisible to human eyes. In 2018, a team from the University of Alberta fed the manuscript into a neural network trained on 400 languages. The AI concluded that it might be written in a heavily abbreviated form of Hebrew. But when they tried to decode sentences, the results were gibberish. Phrases like, "She made recommendations to the priest, man of the house," that sounded vaguely coherent but contextually meaningless. Other models pointed to Turkic, Nahuatl, or even constructed proto-languages no human had ever spoken. What makes the Voynich text so difficult to crack is that it behaves like a real language. Linguists have confirmed that its words follow Zipf's law, a mathematical pattern found in all natural languages, where the most common word appears twice as often as the second most common, and so on. The manuscript's words also cluster in predictable ways, with syntax and structure consistent across its pages. This isn't random scribbling or artistic nonsense. It's deliberate, calculated and consistent, which is precisely what makes its unreadability so haunting. Every now and then, someone claims to have finally solved it. In 2019, a British researcher named Gerard Cheshire announced that he had decoded the entire book, claiming it was written in a proto-Romance language used by medieval nuns. According to Cheshire, the manuscript was a kind of women's health guide filled with herbal remedies, bathing instructions, and astrological advice. His interpretation even identified specific words: turon for turmeric, olada for boil. But his findings were quickly discredited. Linguists pointed out that his translations lacked grammatical consistency and relied heavily on guesswork. The Voynich manuscript had defeated yet another would-be decoder. There's a rhythm to the pattern: discovery, excitement, debunking, silence. Then the process begins again. Even the NSA's top cryptanalysts, who had broken some of the most complex wartime ciphers, failed to make progress. One analyst famously remarked, "The Voynich manuscript makes no sense, but it makes the same kind of no sense everywhere." It's this consistency that fuels another theory: that the manuscript was created using a cipher system so advanced that we've yet to rediscover its logic. Some cryptographers suggest it might involve homophonic substitution, where multiple symbols represent the same letter or sound, scrambled to obscure patterns. Others suspect polyglot encoding, blending multiple languages into a single text. There's even speculation that the manuscript uses non-linear encryption, meaning it can't be read left to right, but in circular layered sequences that require a key lost to time. And then there are those who step beyond the boundaries of conventional explanation. Some claim the book is a relic of alien contact, its script representing a non-human form of communication. Others believe it was created by a time traveler, preserving knowledge in a language immune to translation. More poetic minds see it as a kind of cosmic art, a human attempt to invent meaning where none existed before, the written equivalent of a dream. But maybe the most haunting possibility is also the simplest, that the Voynich manuscript isn't meant to be decoded because it's not communicating anything in the traditional sense. Perhaps its author was experimenting with the very idea of language, creating a structure of symbols to mimic meaning without ever conveying it. In this interpretation, the manuscript becomes a reflection of human consciousness itself, endlessly searching, pattern-seeking, trying to impose logic on chaos. Psychologists have explored this possibility too. They've proposed that the manuscript could be the product of idiolect, a personal language constructed by a single individual, possibly someone experiencing an altered state of mind. The level of fluency suggests the author wrote instinctively, not translating from another tongue, but thinking in Voynichese. If that's true, then decoding it might be impossible, not because it's encrypted, but because it represents a worldview entirely alien to ours, a mental universe that existed only in one person's head. There's also an emotional layer to the mystery. Those who've worked with the manuscript often describe feeling a strange attachment to it, as if it exerts a pull. Some researchers have compared it to staring into the void, seeing reflections of meaning flicker just beyond comprehension. Every time you think you understand a fragment, the logic unravels. It's like chasing a mirage across the desert of time, a pursuit that reveals more about the seeker than the sought. Even in modern times, the manuscript continues to inspire. Artists have recreated its plants as sculptures, musicians have turned its words into melodies, and writers have woven it into fiction as a symbol of the unknowable. It has become more than an object. It's an idea, a challenge, and perhaps a mirror for the limits of human knowledge. The irony is that, in a world driven by instant answers and machine precision, the Voynich manuscript remains beautifully, defiantly unsolved. It's a relic that refuses to be simplified, reminding us that mystery still has value. In a way, it has achieved something rare: immortality through confusion. Maybe the manuscript doesn't hold hidden recipes or lost scientific wisdom. Maybe its true message is silence, a reminder that understanding is not the same as knowing. Its strange script, looping across centuries, may whisper a truth we've forgotten: that the pursuit of meaning is itself the meaning. So the next time you see an image of those cryptic pages, the indecipherable text, the strange plants, the faceless figures floating in green pools, remember that you're looking at more than a code. You're looking at the human condition, written in a language only the unknown can speak. Imagine standing in an open field during a thunderstorm, the sky cracked open with electricity, rain falling like shards of glass, when suddenly a glowing sphere of light drifts toward you. It hovers for a few seconds, humming softly, pulsing like a living thing, before vanishing in a silent flash. That phenomenon, known as ball lightning, has been reported for centuries, yet even today science struggles to explain it. It is one of the strangest and most elusive natural mysteries on Earth, a glowing enigma that defies the laws of physics. Ball lightning isn't just a ghost story or folklore, it's real. People from every culture and era have described it: sailors at sea, soldiers in battle, pilots in the sky, and farmers in the fields. Reports describe luminous orbs ranging from the size of a marble to that of a basketball, often appearing during or after thunderstorms. Some move gently across the ground, others hover at eye level, and a few pass right through windows or solid walls. They can last anywhere from a few seconds to over a minute, sometimes exploding with a loud bang, sometimes disappearing silently as if swallowed by the air itself. The earliest known record of ball lightning dates back to the 12th century, when English monks described a fiery sphere entering their church during a storm and rolling down the nave before vanishing. In 1638, villagers in Devon, England, witnessed a glowing orb burst through a church window, killing several people. Centuries later, during the 1800s, scientists and travelers documented dozens of similar encounters. One famous case occurred in 1857, when a ball of fire reportedly drifted through a French railway car, melting metal but leaving passengers unharmed. Even famous figures have seen it. Russian physicist Pyotr Kapitsa claimed to observe it firsthand, and in the 20th century, Nikola Tesla reportedly tried to create it artificially in his laboratory. In modern times, pilots and astronauts have also reported ball lightning, sometimes mistaking it for unidentified aerial phenomena. In 1963, passengers aboard an airliner flying through a thunderstorm saw a glowing sphere appear inside the cabin, drift down the aisle, and exit through the fuselage, leaving no damage. It's the kind of event that feels impossible, yet there were dozens of witnesses. So, what exactly is ball lightning? The truth is, no one knows for sure. There are many theories, chemical, electrical, and even quantum, but none fully explain all its observed behaviors. Some scientists believe it's a form of plasma, a state of matter where gas becomes electrically charged. In this view, lightning strikes the ground, vaporizing minerals and creating glowing plasma balls that float briefly before dissipating. Others propose that ball lightning is caused by microwave radiation trapped in a plasma bubble, generated by the electromagnetic pulse of a nearby lightning strike. This could explain its ability to pass through glass and solid objects without damage. In 2014, researchers in China accidentally recorded what may be the first verified video of natural ball lightning. During a thunderstorm in Qinghai province, a team of physicists studying ordinary lightning captured a glowing orb appearing near a struck tree. The orb hovered for a few seconds before fading. Spectroscopic analysis revealed traces of silicon, iron and calcium, elements common in soil, suggesting that lightning vaporized the ground and created a glowing, chemically reactive cloud. This vaporized soil hypothesis remains one of the leading explanations today. Yet, even this doesn't solve everything. How does ball lightning maintain its structure for so long? Why does it move intelligently, stopping, turning, even following people, as though aware of its surroundings? Some researchers have proposed quantum coherence, suggesting that ball lightning might be a kind of self-sustaining energy vortex, stabilized by electromagnetic fields in ways we don't yet understand. Others have floated more exotic ideas, such as antimatter interactions, nanobatteries, or micro-black holes formed by intense atmospheric conditions, though these remain speculative at best. Part of what makes ball lightning so fascinating is how unpredictable it is. It can appear anywhere, inside homes, over mountains, in airplanes, or even under the sea. One famous sighting occurred during the siege of St. Petersburg in 1850, where soldiers claimed to see glowing spheres drift above the battlefield, moving slowly among cannon fire before vanishing. Another incident in Siberia described a sphere that entered a home through an open window, floated for nearly a minute, and exploded, leaving burn marks but no fire. It's this combination of wonder and danger that gives ball lightning its mythic aura. In folklore, it's often seen as a supernatural sign, a wandering spirit, a ghost light, or a divine messenger. In rural Europe, people once believed it was the soul of someone struck by lightning, doomed to roam the skies. In parts of Asia, it was seen as a dragon's pearl, a celestial energy drifting between heaven and earth. Even today, pilots who encounter it describe a sense of awe and unease, as if witnessing something alive but unearthly. And perhaps that's part of the truth. Ball lightning may be a natural phenomenon, but it behaves with a kind of personality, appearing rarely, behaving unpredictably, and disappearing without trace. For scientists, it's a reminder that nature still holds surprises we can't fully capture in equations. Every report adds another piece to the puzzle, but the picture remains incomplete. In the end, ball lightning sits at the crossroads of science and mystery. It's not fantasy, but neither is it fully explainable, a flicker of something that exists between the physical and the metaphysical, reminding us how thin the boundary can be. The next time thunder rumbles across the horizon and the air hums with static, look carefully at the sky. Somewhere out there, in the storm's electric heart, a sphere of light might be drifting, glowing with all the unanswered questions of the universe. If the first half of the mystery of ball lightning belongs to eyewitnesses and folklore, then the second belongs to scientists, those who have spent decades chasing light that refuses to be captured. Ball lightning is one of those rare natural phenomena that exist on the border of belief and evidence, where even hard data feels like rumor. You can't summon it in a lab at will, can't predict when it will appear, and can't quite explain how it behaves when it does. Yet its existence is undeniable. Thousands of credible reports over centuries, from pilots to physicists, all describe the same glowing enigma that dances between physics and mythology. For modern researchers, the biggest challenge is recreating the event under controlled conditions. Traditional lightning is well understood, a discharge of static electricity between clouds and the ground. Ball lightning, however, behaves as though it's alive, hovering, splitting, merging, and sometimes even entering enclosed spaces. Scientists attempting to generate it in laboratories often create short-lived plasma spheres using high-voltage discharges or microwaves, but these imitations last mere milliseconds, while natural ball lightning can persist for minutes. The difference suggests that we still don't fully understand the physics of sustained plasma or how atmospheric energy can stabilize into a glowing sphere. One of the most promising theories emerged in the early 2000s, proposed by Russian physicist Evgeny Bychkov. He suggested that ball lightning could form when a bolt of ordinary lightning strikes the ground, vaporizing silica and other minerals in the soil. This creates nanoparticles that bind together into a hot, glowing aerosol. The energy stored in these particles can sustain light for several seconds or even minutes, gradually releasing chemical energy as they oxidize. This nanoparticle combustion model fits many observed characteristics: the spherical shape, slow movement, and lingering brightness. However, it doesn't explain reports of ball lightning passing through solid objects, a phenomenon that defies known physics. That behavior, passing effortlessly through glass, metal, and even aircraft hulls, is among the most puzzling aspects. In one case documented in 1960, Soviet scientists witnessed a glowing sphere enter a room through a closed window, float silently, then exit through another wall without leaving a mark. For decades, skeptics dismissed such stories as exaggerations, but then came the era of cockpit cameras and radar recordings, confirming that unidentified glowing spheres can appear during thunderstorms, sometimes moving in patterns inconsistent with lightning. To explain this, some physicists have turned to electromagnetic field theory. One model, developed by J. Abrahamson and J. Dinnis, proposes that ball lightning could consist of microwave radiation trapped inside a plasma shell. The outer layer acts like a reflective cage, holding the energy within. Such a phenomenon could theoretically pass through materials transparent to microwaves, including glass, explaining why it seems to move through solid barriers. But if true, it implies the existence of self-organizing electromagnetic structures, something rarely seen in nature. Others venture even further. A few speculative physicists propose that ball lightning may represent quantum coherence in atmospheric conditions, localized regions where particles behave collectively, maintaining stability through feedback with the surrounding electromagnetic field. This concept verges on the metaphysical, suggesting the possibility of self-sustaining plasma life forms, or at least plasma patterns, with behavior that mimics intelligence. Though not widely accepted, it's an idea that refuses to die, because so many eyewitnesses describe the light as curious, responsive, or even aware. For instance, in 1978, an Australian pilot reported that a glowing sphere appeared alongside his aircraft during a storm. It maintained a steady distance for nearly a minute, matching his turns and altitude changes before shooting upward and disappearing. Radar detected nothing. A similar event occurred in 1984 when a ball of light entered the cockpit of a Soviet airliner, hovered between the pilots, and exited through the tail. These encounters, described in declassified aviation reports, remain some of the most detailed accounts of ball lightning's bizarre behavior. Even in recent years, with all our instruments and sensors, the phenomenon continues to defy capture. The 2014 Chinese recording remains the closest we've come to scientific proof, but researchers acknowledge that one observation cannot define an entire mystery. Each attempt to recreate it using lasers, microwaves, or electrical arcs produces something that looks similar but never quite the same. It's as if the real thing requires a combination of atmospheric, chemical and electromagnetic factors so precise that it happens only by cosmic coincidence. And maybe that's what gives ball lightning its strange allure. It's a phenomenon that feels like nature experimenting with art, light sculpting itself in air, energy taking temporary shape. We often imagine lightning as violent, destructive, chaotic. But ball lightning is its opposite, calm, deliberate, almost meditative. It's energy in a state of curiosity, lingering just long enough to remind us that the universe isn't done surprising us. In folklore, this glowing sphere has been given many names: St. Elmo's fire, the will-o'-the-wisp, ghost fire, Earth's lantern. Across cultures, people have ascribed meaning to it, from divine omens to wandering spirits. Even sailors, during the age of exploration, saw glowing orbs on their masts and took them as a sign of safe passage. What we now call plasma was once interpreted as presence, the breath of the divine moving through storms. Today, scientists are closer than ever to understanding the physics behind it, yet the mystery remains intact. The equations explain part of it: ionization, magnetic confinement, energy dissipation. But they can't capture the experience of standing beneath one, watching a sphere of living light float silently through the dark. That's the strange gift of ball lightning. It reminds us that not all mysteries vanish under the microscope. Some endure not because they resist explanation, but because they remind us of wonder itself. There's poetry in the idea that even in an age of satellites and quantum computing, we can still look at something glowing in the rain and whisper, "I don't know what that is." And maybe that's the point. Maybe ball lightning exists to remind us that there are still sparks of the unknown flickering within the ordinary world. Brief, beautiful moments when science meets mystery, and both bow in silence before the same glowing light. On the morning of June 30th, 1908, the sky above Siberia ignited. A brilliant fireball streaked across the horizon, followed by an explosion so powerful that it flattened over 80 million trees across 800 square miles of forest. The shockwave was felt hundreds of miles away, shattering windows, throwing people to the ground, and lighting up the night sky for days afterward. Villagers saw a pillar of fire rising into the air and thought the world was ending. Yet when scientists finally reached the site years later, they found no impact crater, no fragments of a meteorite, only endless trees scorched and knocked down in a perfect radial pattern, pointing away from a single point of devastation. The event became known as the Tunguska explosion, named after the remote region near the Podkamennaya Tunguska River in central Siberia. It remains one of the most powerful natural explosions in recorded history, estimated at 30 to 50 megatons of TNT, roughly 1,000 times stronger than the atomic bomb dropped on Hiroshima. And yet, more than a century later, science still can't say with absolute certainty what caused it. At the time, Russia was in political turmoil, and it took nearly 2 decades before an expedition finally reached the site. In 1927, Russian mineralogist Leonid Kulik led a team into the Tunguska wilderness. What they found was staggering. Millions of trees laid out like matchsticks, all pointing away from the epicenter as though blown down by an enormous blast from above. At the center of the devastation was a patch of scorched earth about 5 miles wide, but no crater, no meteorite fragments, no metallic residue. It was as if something had exploded in mid-air and simply vanished. Kulik interviewed local Evenki tribespeople who described a fiery object streaking through the sky, followed by a deafening explosion. Some said they saw the forest burst into flames as a shockwave swept over them. Others spoke of strange atmospheric effects afterward: glowing skies, weeks of warmth in the cold Siberian nights, and a sound like thunder that lasted for hours. The description fit that of an airburst, an explosion that occurs when a large meteor or comet fragment enters Earth's atmosphere and detonates before reaching the ground. But for that much destruction, the object would have to have been enormous, at least 50 to 100 meters across. Modern scientists generally agree that the Tunguska event was caused by a cosmic body, most likely a stony asteroid or icy comet fragment that exploded 5 to 10 kilometers above the surface. As it disintegrated, it released a blast of energy equivalent to multiple hydrogen bombs, flattening the forest below. Yet this explanation still leaves questions. If the object was rocky, why were no fragments ever found? If it was icy, how did it survive entry long enough to explode with such force? And what about the reports of unusual magnetic disturbances or the glowing night skies seen as far away as London and Norway in the days that followed? Some scientists have proposed that the Tunguska body was composed of cometary ice, which vaporized completely upon detonation, leaving no solid remnants. Others believe it may have been a carbonaceous chondrite, a fragile type of asteroid that shattered in the atmosphere, scattering microscopic debris across a wide area. Recent satellite and soil analyses have detected trace amounts of silicate and nickel particles consistent with extraterrestrial material supporting the cosmic hypothesis. But still, no definitive fragments have ever been recovered. Over the years, other theories, some scientific, some sensational, have tried to fill in the gaps. One of the earliest alternate explanations was that the explosion resulted from a natural gas eruption or a volcanic blast, but there are no volcanoes in the area and no evidence of geothermal activity. Another theory suggested a mini black hole passing through Earth, though such an event would have left detectable gravitational effects. Others speculated it was caused by alien technology, perhaps the crash or detonation of an extraterrestrial spacecraft. While those ideas remain in the realm of science fiction, they reveal how deeply the Tunguska mystery captures the imagination. More recent studies using computer simulations have given new life to the airburst theory, showing that a large asteroid traveling at 60,000 kilometers per hour could easily explode mid-air with a yield matching eyewitness reports, vaporizing before hitting the ground. In 2013, a smaller event over Chelyabinsk, Russia, lent support to this model. That meteor exploded high above the Earth with a force of about 500 kilotons, shattering windows across an entire city and injuring over 1,000 people, all without leaving a crater. It was, in essence, a miniature Tunguska. The similarities between the two events suggest that Earth occasionally encounters objects capable of releasing unimaginable energy, even without impact. But beyond the science, there's something haunting about Tunguska's silence. For over a century, nature has reclaimed the land, trees regrown, rivers flowing again, yet the story remains. Locals still tell tales of the fire god that descended from the heavens. Some Evenki elders believe it was a celestial punishment, others a message. For scientists, it's a stark reminder of how vulnerable our planet is, how easily everything we know could be erased by a single unseen rock drifting through space. In the end, Tunguska sits at the intersection of geology, astronomy, and mythology. It's a story of how the universe occasionally reminds us of its power, how something unseen, unheard, and unfathomably distant can reach across the void to shake an entire continent. The forests have grown back, but the questions remain, echoing in the empty Siberian wilderness where trees still fall in a perfect spiral, forever pointing toward the place where the sky once caught fire. Over 100 years after the Tunguska event, the Siberian wilderness still whispers about that morning when the sky exploded. Though scientists now have advanced simulations, satellite imaging, and atmospheric data, the event remains an enigma wrapped in burned earth and folklore. It's one of those rare mysteries where even with all our progress, the final truth slips through our fingers like smoke. After Leonid Kulik's 1927 expedition, more researchers followed, each finding new clues, yet also deepening the puzzle. Soil samples taken from the blast site showed traces of rare metals like nickel and iridium, elements more common in meteorites than in Earth's crust. Tree rings recorded abrupt changes in carbon isotopes, hinting at an extraterrestrial event. And yet, there were no large fragments of rock, no crater, no definitive proof of an impact. The forest itself became the record. Millions of trees flattened outward in a pattern so perfect it looked designed. Later expeditions in the 1950s and 1960s uncovered another strange detail. In the very center of the destruction, a few trees were still standing, stripped bare of their branches but upright, almost as if the blast had come from directly above, pressing them downward rather than sweeping them away. This suggested an explosion that occurred mid-air, not on the ground. Modern models estimate that the object likely detonated between 5 and 10 kilometers above the surface, releasing energy equivalent to 15 to 30 megatons, a force so immense that the shockwaves circled the globe twice. But the exact nature of that explosion remains uncertain. If it were an asteroid, it must have been large enough to create debris, and yet none has ever been recovered. If it were a comet, its icy composition could explain the lack of fragments. But then why was there no water vapor signature detected in later soil studies? Every explanation fits most of the data, but never all of it. This ambiguity has invited some of the strangest theories in modern science. In the 1970s, 2 Soviet scientists suggested that the explosion might have been caused by a tiny fragment of antimatter colliding with Earth's atmosphere. When antimatter meets matter, they annihilate each other, releasing pure energy, enough to level a forest, but leaving behind no trace. The problem, of course, is that such antimatter fragments are incredibly unlikely to exist in our solar system. Others speculated that the event might have been caused by a mini black hole passing through Earth, entering the atmosphere above Siberia and exiting through the North Atlantic. But this too would have produced measurable gravitational effects, none of which were found. Then there's the theory that refuses to die: extraterrestrial intervention. Some authors, most famously Alexander Kazantsev in the 1940s, proposed that the Tunguska explosion might have been the crash or self-destruction of an alien spacecraft. According to this theory, the lack of a crater could be explained by a controlled detonation in the atmosphere and the symmetrical blast pattern by a directed explosion. There's no evidence to support this, but it remains a cultural staple. The idea that something intelligent might have been behind the fire from the sky. Science, of course, remains grounded in what can be measured. Recent computer models suggest that the Tunguska object was likely a fragmented, stony asteroid, perhaps 60 to 100 meters wide, that entered the atmosphere at a shallow angle. The extreme pressure and heat caused it to explode before impact, scattering microscopic debris across the landscape. In 2013, researchers examining Lake Checo, a small body of water about 5 miles north of the epicenter, proposed that it could be a secondary crater created by a smaller fragment that survived the airburst. Sediment core samples from the lake's bottom revealed layers of silt consistent with a formation around 1908. Tantalizing, but not definitive. Yet even if the cause seems nearly solved, the psychological and cultural legacy of Tunguska continues to grow. The Evenki people, whose ancestors witnessed the explosion, still tell stories of a thunder god descending from the heavens, a warning to humankind. Others interpret it as a cosmic accident, a reminder of how fragile our world truly is. At the time, humanity had no way to detect or prevent such an event. Even today, despite decades of progress, a similar asteroid could approach undetected until it's too late. The Tunguska event also sparked a quiet revolution in planetary defense research. It forced astronomers to confront the reality that Earth is not safe from the cosmos. Since then, NASA and other agencies have catalogued thousands of near-Earth objects, NEOs, tracking them with telescopes and satellites in hopes of predicting the next Tunguska before it happens. But even with our current systems, smaller objects, the size of a bus or building, can still slip through unnoticed. The 2013 Chelyabinsk meteor proved that. Its explosion injured over 1,000 people and shattered thousands of windows, a modern echo of Tunguska on a smaller scale. Yet there's something deeply poetic about Tunguska that science alone can't capture. The idea that in a remote forest on the edge of the world, the universe once reached down and touched the earth with fire and then vanished without a trace, carries a mythic weight. It's the kind of event that reminds us how small we are, how brief our presence is against the backdrop of cosmic time. When the night sky glows over Siberia now, it's easy to imagine what it must have been like. The trees trembling, the earth rumbling, the air alive with light. For a moment, the planet itself must have felt aware, like it was waking from a dream of stone and sky. Even now, a century later, the Tunguska event stands as a monument to the unknown. It's both a scientific case study and a legend, proof that the universe still has surprises to offer, and that even in our age of data, we are not done being humbled by the forces that shape our fragile world. Perhaps that's the true lesson of Tunguska, that the cosmos does not owe us explanations. It only reminds us, once in a while, of how easily it can break the silence. On the night of August 15th, 1977, inside a small room at Ohio State University's Big Ear Radio Observatory, astronomer Jerry R. Amon was scanning the skies for radio signals from deep space. The Big Ear telescope was part of the SETI program, the Search for Extraterrestrial Intelligence, and had been listening for any sign that another civilization might be reaching out. Most nights were uneventful, filled with the static hum of cosmic background noise. But that night, something extraordinary happened. For exactly 72 seconds, a powerful, narrow-band radio signal flooded through the receiver, so distinct, so precise, and so unlikely to be natural that it sent chills down Amon's spine. When he reviewed the computer printout, one column of numbers stood out from the rest, 6EQUJ5, the alphanumeric representation of the signal's intensity. Shocked by what he was seeing, Amon circled it in red ink and wrote a single word in the margin: "Wow." The name stuck. From that moment, the "wow" signal became one of the most famous mysteries in modern astronomy, the one time we might have heard from the stars. The Big Ear telescope had detected the signal at 1420.456 MHz, a frequency corresponding to the natural emission of neutral hydrogen, the most abundant element in the universe. This wasn't random. SETI researchers deliberately tuned their instruments near this frequency because it was considered a logical cosmic channel, the universal standard that any intelligent civilization might use to communicate. The signal was exactly where it should be if it were artificial. And yet, in the decades since, no one has ever heard it again. What made the WOW signal so remarkable was not just its strength, but its precision. Natural cosmic sources, pulsars, quasars, or interstellar gases, produce broad, continuous signals. The WOW signal was narrowband, only a few kilohertz wide, just like the signals produced by human transmitters. Its intensity rose and fell exactly as expected, from a point source moving with Earth's rotation, meaning it wasn't interference from a satellite or plane. It came from somewhere in the constellation Sagittarius, near the star group Chi Sagittarii, about 200 light-years away. But when astronomers tried to detect it again, they found nothing. Follow-up observations using the Big Ear, as well as other radio telescopes around the world, came up empty. The signal had appeared once, and then vanished forever. This one-time nature sparked endless debate. If it was an alien message, why didn't it repeat? Some scientists proposed that the signal came from a rotating beacon, perhaps a transmission sweeping across space, only briefly crossing our path. Others suggested it might have been a deliberate ping, a kind of interstellar handshake meant to see if anyone was listening. Skeptics, however, offered more mundane possibilities. Some suggested it could have been terrestrial interference, a reflection of a military or communication satellite signal. But at the time, no satellite was transmitting on the hydrogen frequency, which is internationally protected for astronomical use. Others theorized it might have been a comet, emitting hydrogen gas that briefly mimicked a radio signal as it passed through the telescope's field of view. In 2017, astronomer Antonio Paris proposed that comets 266P/Christensen and 335P/Gibbs were near that region of the sky in 1977 and could have been responsible. Yet further studies showed that comets produce signals too weak and too broad to match the precision of the WOW event. The mystery deepened when scientists realized just how narrow the timing window was. The Big Ear telescope had two feed horns, each observing adjacent parts of the sky for 72 seconds as Earth rotated. The WOW signal appeared in only one horn, meaning it was detected during a single pass, a window so brief that any attempt to re-observe it minutes later would have missed it entirely. That 72-second burst has since become one of the most studied data sets in radio astronomy. Its profile perfectly matches what SETI researchers predicted an extraterrestrial signal would look like: a sudden rise, a steady peak, and a gradual fall as the telescope's beam passed over the source. The power curve is almost too perfect to be random. And yet, without repetition, science has no way to verify it. For decades, the WOW signal has been a kind of cosmic ghost story, a data point that refuses to die. Every few years, someone claims to have found a new explanation, and every time, the evidence falls short. The truth remains suspended somewhere between science and wonder. It's tempting to imagine what it might have been. A signal sent centuries ago from a civilization long gone. A transmission beamed deliberately into space, crossing light years to brush against our world for a moment. A whisper from the dark saying, "You are not alone." To this day, SETI researchers still scan the same region of Sagittarius, hoping to hear it again. New telescopes, like the Allen Telescope Array and Breakthrough Listen projects, have dedicated thousands of hours to searching for narrowband signals, yet none have matched the WOW event's clarity. Some believe that the signal was real, a genuine artifact of intelligent origin, and that we simply haven't looked at the right time again. Space is vast, after all, and our listening window tiny. Others think it may forever remain a one-time cosmic accident, a mystery without an answer. But whatever it was, the wow signal changed how humanity listens to the universe. It reminded us that in all our searching, even a single whisper can be enough to reignite the ancient question, are we alone? Some mysteries don't need repetition to matter. Sometimes one perfect sound, one fleeting anomaly, is enough to change how we see ourselves. And somewhere out there, perhaps a few hundred light-years away, the source of that signal still travels through space, indifferent to our wonder. It could have been a machine, a civilization, or just noise in the cosmic static. But in that one brief moment, on a warm night in 1977, humanity heard something that felt like an answer. After that fateful summer night in 1977, the wow signal became more than a scientific anomaly. It became a symbol of cosmic possibility. It forced humanity to confront an uncomfortable truth. For all our progress, we might have already heard from another world and simply missed our chance to reply. The Big Ear's paper roll, that single strip of code marked with a red pen, remains one of the most iconic artifacts in the history of astronomy. But beneath the excitement lies a haunting silence. In nearly 5 decades of searching, nothing like it has ever been heard again. Following Jerry Amon's discovery, teams across the globe mobilized to re-scan the signal's origin point near Chi Sagittari. The Big Ear telescope observed the area dozens of times, hoping to capture a repeat. Other observatories in Puerto Rico, Harvard, and Australia joined the effort. Yet each time, the instruments returned nothing but static. The cosmos, it seemed, had gone quiet again. Part of the challenge is statistical. The universe is vast, and the odds of Earth's rotation aligning again with a potential narrow signal source are slim. Even if the wow signal were an intentional transmission, the timing might never repeat within a human lifetime. Imagine shining a flashlight across a field. Anyone standing in its beam for a second would see the light, but everyone else would see only darkness. The wow signal could have been just that, a fleeting intersection of two civilizations in time and space. As years passed, technology advanced, and so did the theories. The SETI Institute, founded in 1984, made the search more systematic. New projects like Project Phoenix and Breakthrough Listen expanded the scope to billions of radio frequencies, monitoring thousands of stars for even the faintest anomaly. Still, no second wow signal ever came. In 1997, Amon himself was asked whether he believed the signal was extraterrestrial. His reply was cautious but revealing. We should have seen it again, but the fact that we didn't doesn't mean it wasn't real. His words echo a truth about scientific mystery. Absence of repetition is not proof of absence. The signal existed. It was recorded. And in its brief 72-second lifespan, it defied every known natural explanation. That hasn't stopped skeptics. Some claim it could have been radio interference bouncing off space debris. Others point to terrestrial reflections, stray signals echoing from distant satellites. Yet these explanations always fall short of explaining the frequency, strength, and precision of the reading. The hydrogen line is sacred territory for astronomers, protected and monitored globally to avoid contamination. No human-made source has ever been known to transmit exactly at 1420 MHz. Even modern analyses using artificial intelligence haven't solved it. In 2022, researchers reprocessed the wow signal data using advanced algorithms capable of detecting hidden patterns. The conclusion? The signal was genuine, uncorrupted and distinct from any background noise. It wasn't random. It wasn't an error. It was something real, something that spoke once and never again. Philosophically, the wow. Signal changed how scientists think about communication with other worlds. It demonstrated that the universe doesn't need to shout to be heard. Sometimes a whisper is all it takes. It inspired countless films, novels, and debates, from Contact to Interstellar, all centered on the same aching question. If someone out there did speak, would we even understand it? The human imagination filled the silence with possibilities. Perhaps it was a probe, a transmission aimed at thousands of worlds, hoping for a reply from any that could hear. Maybe it came from a civilization that no longer exists, their world destroyed while their message drifts endlessly through the void. Or perhaps, and this thought chills many scientists, the signal wasn't meant for us at all. We just happened to intercept it, like overhearing a conversation not intended for our ears. There's also the emotional side of it, the feeling of the wow signal. For those who've spent their lives staring into space, the discovery represents both hope and loss. Hope, because it suggests intelligence beyond Earth might truly exist. Loss, because it may have been our only chance to connect, lost in the noise of cosmic time. The moment came and went before anyone even realized its importance. Today, Big Ear no longer exists. The telescope was dismantled in 1998 to make way for a golf course, a quiet, almost poetic metaphor for how easily great mysteries can be buried under everyday progress. But the spirit of the wow, signal lives on in the data and in every antenna that turns toward the stars, listening. New instruments like FAST in China and the Cant array in South Africa can detect signals far weaker than Big Ear ever could. Each year, SETI researchers comb through terabytes of data, looking for patterns that might resemble that unforgettable 6EQUJ5 curve. And every year, the silence grows deeper. But so does the determination. For scientists, the wow. Signal is not a disappointment, but a challenge. It reminds them that mystery is the engine of discovery. For dreamers, it's something else entirely, proof that even in a universe as vast as ours, a single moment of connection can mean everything. Maybe one day, when technology catches up, we'll hear it again. Another signal from the same region, or perhaps from somewhere new. Maybe this time, we'll be ready to respond. Until then, the wow. Signal remains a single spark in the great dark ocean. A cosmic hello still echoing through our collective imagination. Because in the end, whether it was aliens or anomaly, the message was clear. We are listening. And perhaps, somewhere far beyond the reach of our telescopes, someone, or something, heard us too. Imagine living in a small, quiet town surrounded by the vast deserts and mountains of New Mexico. A place so still that you can hear the wind dance through the sagebrush. But then, one night, you notice it, a faint, low humming sound. It's not loud, but it's constant, like a diesel engine idling somewhere in the distance. You ask your neighbors, and some hear it too, while others insist there's nothing there. Weeks pass, the hum never stops. It's always there, steady, droning and maddening. This is the strange story of the Taos hum, one of the most persistent and unexplained acoustic mysteries in modern history. The phenomenon takes its name from Taos, New Mexico, a small artist town nestled in the Sangre de Cristo Mountains. Since the early 1990s, hundreds of residents have reported hearing a low-frequency sound, usually described as a faint buzzing, droning or humming noise that seems to come from nowhere and everywhere at once. For some, it's barely noticeable, a distant background vibration. For others, it's life-altering, disrupting sleep, concentration, and even mental health. What makes it stranger is that not everyone hears it. Two people can stand in the same room, and one will swear the hum is deafening, while the other hears absolute silence. The reports became so widespread that in 1993, Congress requested an official investigation by scientists from Los Alamos National Laboratory, the University of New Mexico, and Sandia National Laboratories. The team conducted a full study using sensitive microphones, seismographs, and electromagnetic detectors to trace the sound's source. They recorded background noise, interviewed residents, and analyzed environmental data. Their findings? Nothing unusual. No consistent frequency, no industrial vibration, no mechanical cause. Yet the people of Taos continued to hear it. What makes the Taos hum so compelling is that it's not unique. Similar phenomena have been reported around the world: the Bristol hum in England, the Largs hum in Scotland, the Kokomo hum in Indiana, and the Auckland hum in New Zealand. In each location, a small percentage of the population hears a persistent low-frequency noise, typically between 30 and 80 Hz, just at the edge of human hearing. Microphones often detect nothing, suggesting the sound might not be external at all. One explanation is that the hum isn't a sound, but a perception, a kind of auditory hallucination caused by the brain's internal sensitivity to low frequencies. Some scientists propose that hearers, or hummers, have an unusual ability to perceive subtle vibrations or pressure changes that most people can't detect. This sensitivity might stem from inner ear differences or even microseismic vibrations amplified by local geology. In places like Taos, where the Earth's crust has unique mineral layers, it's possible that natural resonance amplifies certain frequencies, a geological echo that only some people's ears can interpret as sound. But others aren't convinced. Many residents claim the hum feels mechanical, not natural, a vibration they can sense through the floor or chest, sometimes strongest indoors and worse at night. Some have blamed distant factories, underground pipelines, military radar, or power lines. One theory points to very low-frequency VLF radio waves used by submarines for long-distance communication. These electromagnetic signals can interact with the ionosphere and sometimes produce audible side effects in sensitive environments. But again, nothing definitive connects these signals to Taos. For those who experience it, the hum isn't just annoying, it's haunting. People describe feeling physically trapped by it, as if the town itself is vibrating beneath their skin. Some wear earplugs or noise-cancelling headphones, but it doesn't help. The sound isn't coming through the ears, but seems to resonate inside the skull. Psychologists studying the phenomenon note that the hum often leads to sleep deprivation, anxiety, and even depression, turning what might be a subtle environmental noise into a psychological torment. Interestingly, there are also reports of fluctuating intensity, with some residents claiming the hum changes pitch or follows them when they move. This has led to more speculative ideas, some even bordering on the paranormal. A few locals have suggested that the hum is connected to Earth's natural electromagnetic field, or that it could be a byproduct of secret military experiments in the region. Taos is, after all, not far from Los Alamos and Area 51, two names steeped in mystery. Others, more mystically inclined, believe it might be the heartbeat of the earth, a spiritual vibration that only certain people are attuned to hear. Still, scientists remain cautious. Studies conducted in similar hum towns have shown small correlations with industrial sources, ventilation systems, distant compressors, or even wind turbines, but none consistent enough to explain Taos. In 2003, a group of British researchers studying the Bristol hum discovered that residents' sensitivity often increased during periods of stress, suggesting that psychological amplification might play a major role. In essence, once you notice the hum, your brain can't stop listening for it, turning it into a self-sustaining loop. And yet, the Taos hum has endured. New residents occasionally report hearing it for the first time, describing the same sensation, a low, inescapable drone that no one else can hear. Over time, it's become part of Taos folklore, a riddle that blends science, psychology, and the supernatural. Whether the hum is a product of physics, biology, or imagination, it represents something deeply human, our need to make sense of the invisible forces around us. For those who hear it, it's a reminder that even silence isn't truly silent. The world hums, breathes, and vibrates in ways we can't always measure, a subtle rhythm beneath the surface of life itself. As night falls over Taos, the desert quiet stretches endlessly, broken only by the occasional rustle of wind or a coyote's call. And yet, for some, the hum is always there, a ghostly tone echoing just below the threshold of hearing, as steady and mysterious as the stars above. While Taos may be the most famous, it's far from the only place where the world seems to hum. Reports of low-frequency sounds that no one can locate stretch across continents, from the rocky coasts of England to the empty deserts of Australia. Each version of the mystery sounds eerily familiar, a deep, thrumming vibration that some hear and others can't. Scientists call these phenomena global hums, but for those who experience them, they often feel like something more, as though the planet itself is singing a note only a few of us can hear. Take Bristol, England, for instance. In the late 1970s, hundreds of residents began complaining about a strange, low rumble that seemed to hover in the air at night. It was loud enough to shake windows, subtle enough to evade microphones, and consistent enough to drive people from their homes. The British government launched an inquiry, but found nothing conclusive. The hum was real to those who heard it, yet completely invisible to instruments. A similar case unfolded in Windsor, Ontario, where citizens blamed the industrial operations of nearby Zug Island for a sound that came and went for years. Even when factories shut down, the hum sometimes continued, defying all logic. In Kokomo, Indiana, engineers traced a persistent hum to two industrial fans, producing overlapping low frequencies. When the fans were turned off, the hum faded, but not entirely. Some residents still heard it, long after the supposed cause was removed. This blurred line between physical and psychological sound fascinates researchers. It suggests that once a sound embeds itself in our consciousness, the brain can replay it, independent of the outside world. This phenomenon is known as auditory memory persistence, and it may explain why some hearers claim the hum follows them wherever they go. The human ear can typically detect frequencies between 20 Hz and 20,000 Hz, but sensitivity to extremely low vibrations varies from person to person. Those who report hearing the hum often describe sensations rather than pure sound, pressure in the ears, vibration in the chest, or a subtle trembling beneath their feet. This implies that what they perceive may not be sound in the usual sense, but infrasound, vibrations below the threshold of hearing that the body can still feel. Infrasound is known to be produced by natural processes like ocean waves, volcanic activity, and even atmospheric turbulence. Some scientists believe that global hums may simply be a form of planetary background noise, the Earth's own deep-frequency resonance reverberating through land and sea. This concept isn't as far-fetched as it sounds. Geophysicists have discovered that our planet constantly vibrates at a low frequency, even when no earthquakes occur. These microseisms are generated by interactions between the atmosphere, the oceans, and the crust. When waves collide in the open ocean, they create pressure pulses that travel through the seafloor and echo across continents. The result is a faint, steady hum, a natural oscillation at around 10 millihertz, far below human hearing. Instruments can record it, but our ears cannot. Yet for reasons not fully understood, a small percentage of people might unconsciously detect its harmonics. If true, this would mean that the Taos hum and others like it could be the first human encounter with the planet's hidden rhythm, the heartbeat of Earth. Some cultures have long believed in this idea. Indigenous traditions speak of the song of the land, while Eastern philosophies refer to OM, the universal vibration that underlies all existence. In these interpretations, the hum isn't a nuisance but a connection, a reminder that the Earth itself is alive and resonating. Of course, not everyone agrees. Engineers still suspect man-made sources are behind many hums. Modern life produces countless low-frequency sounds, from diesel engines and ventilation systems to wind turbines and underground tunnels. Sound waves at these frequencies can travel for miles, refract around obstacles, and bounce off atmospheric layers, creating echoes that confuse our perception of direction. Some researchers argue that the Taos hum could be caused by multiple faint sources blending together, a kind of acoustic illusion formed by overlapping frequencies. Yet even this doesn't explain why only certain people hear it. Studies suggest that hearers tend to be between 40 and 70 years old and often have above-average hearing sensitivity in the low-frequency range. There's even speculation that genetics could play a role, a predisposition that makes certain individuals more attuned to infrasound or more likely to experience auditory resonance within their own skull. In other words, the hum might be both external and internal at once, a fusion of environment and biology. Then there's the psychological dimension. When people live with an unexplained sound for long enough, their minds adapt around it. The hum becomes not just a sensation, but an identity, a personal mystery that shapes daily life. Some form online communities where hummers share coping strategies, audio recordings, and new research findings. A few have turned to meditation, learning to reinterpret the hum not as an irritation, but as a rhythm to breathe with. In Taos, some artists even use the legend as creative inspiration, transforming frustration into art, poetry, and music. Despite decades of study, no one has definitively explained the Taos hum. It could be a convergence of environmental vibrations, subtle electromagnetic frequencies, and human sensitivity, or something entirely beyond our current understanding. But one thing is certain: the phenomenon blurs the boundary between the physical and the psychological, showing how perception itself can become a mystery. When the desert grows still at night and the stars hang low over Taos, some say the hum grows louder, a slow, endless drone beneath the sound of crickets and wind. Whether it comes from the earth, the air, or the mind, no one knows. But perhaps that's what makes it so haunting. It's not just a sound you hear, it's a sound that listens back. In a world where almost every secret has been cracked open by science and code breaking, there remains one stubborn mystery that refuses to yield. A book filled with strange symbols, surreal plants, and illustrations that seem to defy logic. It's known as the Voynich manuscript, and for over 600 years, no one has been able to read a single word of it. Bound in soft vellum and written in an unknown script, the manuscript looks like something straight out of a dream. Its pages are filled with looping letters that don't match any known alphabet, accompanied by illustrations of plants that don't exist, astronomical diagrams of unfamiliar constellations, and scenes of tiny nude women bathing in pools connected by flowing tubes. It's as if the author was documenting an entire world parallel to our own, one governed by different laws of nature and language. The story begins in 1912, when an antique bookseller named Wilfrid Voynich purchased the manuscript from a Jesuit library near Rome. Voynich, who was fluent in multiple languages and a scholar of rare texts, immediately recognized that he had found something extraordinary. The book appeared to date back to the early 15th century, and its script, which later came to be called Voyniches, was unlike anything scholars had ever seen. Voynich spent years trying to decode it, convinced that it was a lost alchemical treatise or a secret work of medieval science. When experts examined the manuscript, they were baffled. The writing wasn't random scribbling. It had patterns, repeating words, consistent syntax, and a structure that suggested genuine language. Yet it matched nothing known from any human tongue. Cryptographers, linguists, and even codebreakers from both world wars tried to decipher it, including members of the US NSA. None succeeded. Some thought it was a cipher, an encrypted text hiding sensitive knowledge. Others believed it to be a constructed language, invented by a genius mind to conceal meaning itself. In 2009, radiocarbon dating confirmed that the parchment was created between 1404 and 1438, firmly placing it in the European Middle Ages. That ruled out modern forgery. The materials were genuine. But it only deepened the puzzle. If it wasn't a hoax, then what was it? The manuscript's contents can roughly be divided into 6 sections: botanical, astronomical, balneological, bathing and health, cosmological, pharmaceutical, and recipe. Yet each is filled with absurdities. The plants are hybrids of species that don't exist. The astronomical drawings depict stars and moons connected by impossible geometry. The bathing women scenes look both whimsical and anatomical, as if describing biological systems through fantasy imagery. Whoever created it clearly had a plan, but one no one else can follow. Throughout the 20th century, theories multiplied. Some claimed the manuscript was the work of Roger Bacon, the 13th century English philosopher who was rumoured to dabble in secret alchemical writings. Others suggested it came from Leonardo da Vinci in his youth, a product of his imagination and mirror writing. Still others proposed that it was created by John Dee and Edward Kelly, 2 Elizabethan mystics who claimed to speak to angels through coded symbols. But none of these claims matched the dating or the style. Then there's the linguistic puzzle. Statistical analysis reveals that the text follows natural language laws, word frequencies and distribution patterns identical to those found in real human languages. But its words and grammar don't correspond to anything known. The script consists of 20 to 30 distinct characters, often grouped into syllable-like patterns. Some scholars believe it's a kind of constructed proto-language, possibly made to encode scientific ideas without reliance on any spoken tongue. Others think it may use an algorithmic cipher centuries ahead of its time, a kind of medieval encryption we've yet to fully understand. In recent years, digital technology has breathed new life into the mystery. In 2017, a group of Canadian computer scientists used artificial intelligence to analyze the manuscript's patterns, claiming it might be a form of encoded Hebrew. Their algorithm translated some passages into phrases that loosely resembled herbal recipes and astrological instructions. However, linguists quickly debunked the claim, arguing that the results were too vague and inconsistent to be meaningful. Even more intriguing are the illustrations. Some researchers note that the manuscript's plants appear to combine parts of real species known from Asia, Africa and Europe, suggesting that the author might have travelled widely or drawn inspiration from trade routes that connected far-flung regions. Others think the book could represent a compendium of lost knowledge, possibly written in a private code to protect sacred or scientific information during an age of religious persecution. But the strangest thing about the Voynich manuscript is its emotional pull. People who study it describe an uncanny sense of familiarity, as if the text almost makes sense but slips away the moment you think you understand it. The pages seem to hum with intelligence, suggesting meaning just beyond reach. Cryptographers have compared it to staring into a mirror that reflects another world, one where the rules of language evolved differently. And perhaps that's why the manuscript continues to captivate modern minds. It exists at the intersection of science, art, and enigma, a relic that refuses to belong to any category. Whether it's a coded alchemical guide, an alien script, or simply an elaborate work of medieval imagination, the Voynich manuscript remains one of the few mysteries that technology hasn't solved. To this day, it sits safely preserved in the Yale University's Beinecke Rare Book Library, where researchers and dreamers alike can view its digitized pages online. Each line of its strange, looping text continues to defy translation, whispering a language that seems meant for no one but itself. Perhaps the author never intended anyone to read it. Maybe it wasn't a code to be cracked, but an act of creation, a world written in symbols only its creator could understand. Whatever the truth, the Voynich manuscript stands as a reminder that mystery is not the opposite of knowledge, but its twin, forever drawing us forward, inviting us to listen to what we cannot yet comprehend. The deeper scholars dig into the Voynich manuscript, the stranger it becomes. Every time someone claims to have solved it, the mystery only tightens its grip. For over a century, code breakers, linguists, and dreamers have stared at its curling script, convinced that the key must be there, hidden between the lines, waiting for someone to understand it. Yet no matter how sophisticated the tools become, the language of the Voynich manuscript refuses to yield. It stands like a wall of symbols guarding a secret that no one alive has the context to read. The most advanced attempts to decode the manuscript have used artificial intelligence. In 2018, a team at the University of Alberta trained a computer algorithm on dozens of known languages, teaching it to identify linguistic patterns and match them to real-world tongues. When they fed the Voynich text into the program, the AI suggested it most closely resembled Hebrew, though scrambled with missing vowels and rearranged grammar. Translating the first few lines, the program produced vague sentences, words like light, air, and farmer. But experts soon realized that with enough flexibility, any gibberish could be forced to resemble something meaningful. The translation was too uncertain to count as proof. Other computer models have compared Voynichese to Romance languages, like Latin or Old Italian. Linguist Stephen Bax made headlines in 2014 when he claimed to have identified a handful of words: Taurus, juniper, coriander. His reasoning was simple. Many of the illustrations seemed to match identifiable plants and constellations, so he cross-referenced the symbols near them with possible names. His translation fit just enough to feel promising, but nowhere near enough to read full sentences. Bax himself admitted that he had likely unlocked only fragments of a much larger code. Some scholars have argued that the Voynich manuscript isn't written in any human language at all, but in a form of glossolalia, or automatic writing. According to this theory, the author may have entered a trance-like state, writing intuitively without conscious meaning. This idea gained traction among psychologists who note the text's rhythmic repetition and symmetrical patterns. It could have been the product of an inspired, obsessive mind, someone compelled to write for reasons even they didn't understand. If that sounds far-fetched, consider the human capacity for pattern creation. In medieval Europe, mystics, alchemists, and scholars often used symbolic writing to record visions, formulas, or revelations. Many believed divine or cosmic truths couldn't be expressed in ordinary words. To them, the Voynich manuscript might not be nonsense at all, but a sacred attempt to encode spiritual knowledge into an unearthly script. There's also a darker possibility, that the manuscript is the work of a brilliant forger or trickster from centuries ago. Some historians argue that it could have been created as an elaborate hoax to sell to a wealthy collector or patron fascinated by alchemy and mysticism. In this view, the text was designed to look meaningful, complete with linguistic structure and consistent grammar, but actually means nothing. Yet this theory falters under scrutiny. Producing such a detailed and mathematically coherent fake language by hand, page after page, would have required not just creativity, but genius-level understanding of linguistics, centuries before such concepts even existed. For those who've seen the original pages up close, there's an uncanny beauty to the work that feels too purposeful to be empty. The handwriting is fluid and deliberate, showing none of the hesitation you'd expect from someone inventing nonsense. The ink's consistency, the uniform margins, and the carefully shaded illustrations all point to a disciplined process. Whoever wrote it wasn't experimenting, they were documenting something. One of the most captivating theories emerged from a team of historians in Italy who proposed that the manuscript may have originated in northern Italy, possibly as a compendium of women's health and herbal medicine. The bathing scenes, they suggest, could depict medieval hygiene rituals or fertility treatments, encoded in secrecy during a time when such knowledge was taboo. The strange plants might represent mixtures of real herbs, drawn abstractly to hide their identity. In this theory, the Voynich manuscript could be one of the earliest examples of coded medical literature, authored by midwives or healers working under the shadow of persecution. Still, none of these explanations fit neatly. Every new hypothesis adds more layers, not fewer. Even the book's astronomical diagrams, swirling orbs with looping stars and suns, remain ambiguous. Some see them as astrological charts, others as depictions of alternate cosmologies. The famous Rosette map, a fold-out page filled with circular city-like structures connected by tunnels, looks like both a star map and a blueprint, depending on how you interpret it. The manuscript seems to resist categorization, as though it's aware of being studied and determined to stay silent. What makes the Voynich manuscript so haunting is how close it feels to making sense. Experts describe a near comprehension when reading it, the sense that if you stare long enough, the symbols might suddenly align, revealing a logic you were too limited to see before. But that revelation never comes. It's a constant dance between understanding and mystery, like trying to remember a dream you had just before waking. Even the manuscript's current home adds to its mystique. Locked inside the temperature-controlled vaults of Yale's Beinecker Library, the Voynich rests like an oracle from another age. Scholars who handle it describe the texture of the vellum, smooth, faintly warm, and the ink that still gleams after 6 centuries. For all our technology, the best we can do is scan it, model it, and marvel at it. No computer, cryptographer, or historian has yet found the cipher's key. And maybe that's the secret the Voynich holds, that there is no key. Perhaps it was never meant to be read by us at all. Maybe it was written for a different world, a different kind of mind, or even for the writer alone, a private universe in ink. The Voynich manuscript is more than an unsolved puzzle. It's a reflection of our hunger to know, to translate the unknown into human meaning. Every theory, every algorithm, every sleepless night spent tracing its glyphs is an act of faith that somewhere in the silence of those pages lies an answer. And perhaps that's what keeps us chasing it, not the hope of deciphering the text, but the wonder of knowing that some mysteries still refuse to speak. Look up at the night sky. Every star you see, every glowing speck scattered across the cosmos, makes up less than 5% of the universe. The rest? It's invisible, unseen, untouchable. But it's there, shaping galaxies, bending light, and quietly holding the entire cosmos together. Scientists call it dark matter, and it's one of the greatest mysteries in all of physics. A shadow world that outnumbers everything we can see by a staggering margin, yet has never been directly detected. The story of dark matter begins not with telescopes, but with a problem. In the 1930s, Swiss astrophysicist Fritz Zwicky was studying the Coma cluster, a group of galaxies bound together by gravity. According to Newton's laws, the visible matter, stars, gas, and dust, shouldn't have been enough to hold the cluster together. The galaxies were moving so fast that the cluster should have torn itself apart. Yet it didn't. Something unseen was exerting extra gravity, keeping everything bound. Zwicky called it dunkle Materie, dark matter. For decades, the idea was little more than a footnote. It wasn't until the 1970s that evidence for dark matter began to pile up. Astronomer Vera Rubin, studying the rotation of spiral galaxies, discovered something extraordinary. The stars near the outer edges of galaxies were moving far too fast, as if being pulled by an invisible force. In a normal system, the farther you move from the center, the slower you should orbit, just like planets around the Sun. But in Rubin's data, the speeds stayed constant, as though the galaxies were embedded in enormous halos of unseen mass. Rubin's work was revolutionary. It confirmed that most of the matter in the universe isn't luminous. It doesn't emit, reflect, or absorb light. It simply exists, silently influencing everything else through gravity. If galaxies were ships sailing through space, dark matter was the vast, invisible ocean beneath them. So what is this stuff made of? That's where the mystery deepens. Despite decades of searching, no one knows. Dark matter doesn't interact with light or electromagnetic forces, which makes it nearly impossible to detect directly. Scientists can only infer its presence through its gravitational effects, the way it bends light from distant galaxies, a phenomenon called gravitational lensing, or alters the structure of the cosmic microwave background, the faint afterglow of the Big Bang. The leading candidates for dark matter are a class of hypothetical particles known as WIMPs, weakly interacting massive particles. These particles, if they exist, would have mass and gravity, but would barely interact with normal matter passing through us and the Earth itself, billions of times each second without leaving a trace. Experiments deep underground, such as those at the Gran Sasso Laboratory in Italy or the LUX Zeppelin detector in South Dakota, have spent years trying to capture a single WIMP interaction. So far, nothing. Another theory involves axions, ultra-light particles that could form a vast cosmic field permeating space. They're invisible, but they might subtly affect electromagnetic radiation. Scientists are building sensitive detectors, using everything from superconducting magnets to microwave cavities, to try to hear axions humming in the background of the universe. And yet, despite the ingenuity of these efforts, the universe remains silent. Some physicists argue that perhaps dark matter isn't matter at all. Maybe our understanding of gravity is incomplete. The modified Newtonian dynamics, MOND hypothesis, proposed by Israeli physicist Mordechai Milgram, suggests that gravity behaves differently on cosmic scales, weakening less than expected at vast distances. If true, that could explain galaxy rotation curves without invoking dark matter. But MOND struggles to explain other phenomena like galaxy cluster behavior and gravitational lensing, which dark matter predicts perfectly. The evidence for dark matter's existence goes far beyond galaxies. When scientists map the cosmic web, the vast network of filaments and voids that make up the universe, they find that visible matter alone can't account for its structure. Computer simulations using dark matter produce results that match the real universe almost perfectly, suggesting that whatever it is, dark matter sculpts the very shape of cosmic evolution. In 2006, astronomers studying the Bullet Cluster, two colliding galaxy clusters 3.8 billion light-years away, found one of the most striking pieces of evidence yet. When the clusters crashed, their normal matter, mainly hot gas, interacted and slowed down. But their gravitational fields, mapped using gravitational lensing, passed straight through one another, as if the true mass of the clusters was invisible and unaffected by the collision. This separation between visible and gravitational mass is considered a smoking gun for dark matter. Still, the deeper we look, the stranger it gets. Some researchers speculate that dark matter might have its own dark versions of physics, dark atoms, dark forces, even dark light that we simply can't perceive. In this theory, there could be an entire dark universe interwoven with ours, invisible but parallel, perhaps even capable of forming dark galaxies or dark stars. If that's true, then most of existence might be hidden behind a curtain of physics we're not yet equipped to understand. And perhaps that's the real allure of dark matter. It's not just about missing mass. It's about the possibility that the universe is infinitely richer and stranger than what we can see. Every time we peer into the night sky, we're not just looking at stars and galaxies. We're staring through a vast ocean of the unseen. Dark matter reminds us that the universe still keeps secrets, that even in an age of satellites, supercomputers, and particle accelerators, there are forces shaping our world that lie beyond detection. Somewhere out there, drifting between galaxies, is the invisible skeleton of the cosmos, silent, eternal, and still waiting to be understood. If dark matter is the invisible glue holding the universe together, dark energy is the force tearing it apart. It's the silent expansion between galaxies, the unseen wind pushing the cosmos outward faster and faster. Together, dark matter and dark energy make up about 95% of the universe, meaning that everything we've ever observed, studied, or built our theories upon represents just a sliver of reality. The rest lies hidden in the dark. The story of dark energy begins with a surprise. In 1998, two teams of astronomers studying distant type Ia supernovae, stellar explosions so bright they can outshine entire galaxies, were trying to measure how fast the universe's expansion was slowing down. According to all expectations, gravity from galaxies and dark matter should have been gradually pulling everything inward, slowing the cosmic expansion that began with the Big Bang. But when the data came back, it told a very different story. The universe wasn't slowing down, it was accelerating. That discovery shocked the scientific world. To explain it, researchers proposed that some unknown form of energy, filling all of space itself, must be driving galaxies apart. This mysterious phenomenon was dubbed dark energy. Overnight, the cosmic narrative changed. Instead of a universe winding down, we live in one speeding up, racing ever faster toward the unknown. But what exactly is dark energy? No one knows. It's not a substance we can detect, not radiation, not a particle. The simplest explanation comes from Einstein's cosmological constant, lambda, a term he added to his equations of general relativity in 1917 to keep the universe static. When he later learned the universe was expanding, he called it his biggest blunder. Decades later, that same term returned as a candidate for dark energy, representing the energy density of the vacuum of space itself. In other words, even empty space has energy, and that energy exerts a repulsive force. It sounds abstract, but it's real. Quantum physics predicts that even in a perfect vacuum, virtual particles constantly appear and disappear, fluctuations that contribute a tiny bit of energy. When multiplied across the infinite expanse of space, this vacuum energy could explain why the universe accelerates. The problem is that quantum calculations predict a value far larger, 120 orders of magnitude greater than what astronomers observe. This discrepancy, often called the worst theoretical prediction in physics, remains one of science's most perplexing problems. Other theories paint different pictures. Some physicists propose that dark energy isn't constant but dynamic, an evolving field known as quintessence. In this model, dark energy's strength changes over time, subtly altering the rate of cosmic expansion. Others suggest it could be a byproduct of higher dimensional physics, with gravity leaking into or from parallel universes. A few radical thinkers even speculate that dark energy might not exist at all, that instead our understanding of gravity breaks down at large scales, producing the illusion of acceleration. Yet the evidence for dark energy keeps growing. Observations of the cosmic microwave background, CMB, the faint afterglow of the Big Bang, show patterns that only make sense if dark energy exists. Measurements from the Planck satellite and baryon acoustic oscillations, BAO data, all confirm that roughly 68% of the universe is composed of this mysterious energy. We can't see it, but we can see what it does. It stretches the fabric of space-time itself. To visualize it, imagine painting dots on a balloon and then inflating it. The dots, galaxies, move farther apart, not because they're flying through space, but because space itself is expanding between them. Dark energy is that expansion, working on the grandest possible scale. Every second, the universe grows larger, galaxies drift farther, and the night sky becomes a little darker. But this raises a haunting question. What happens next? If dark energy continues to dominate, the universe's expansion will never stop. Over billions of years, galaxies will drift so far apart that light from one can no longer reach another. Stars will die, planets will freeze, and even atoms may one day decay, a scenario cosmologists call the Big Freeze. Time will stretch endlessly into silence, a cold, empty universe still expanding, but devoid of light or life. Other scenarios are even more dramatic. If dark energy grows stronger over time, its repulsive force could eventually overcome all other forces, tearing apart galaxies, stars, planets, and even atomic particles in a catastrophic event known as the Big Rip. In that future, not even the laws of physics as we know them would survive. Of course, we're nowhere near understanding dark energy's true nature. Experiments like the Dark Energy Survey, DES, and the Euclid Space Telescope, launched by the European Space Agency, are trying to map the universe's expansion with unprecedented precision. By studying how galaxies cluster and how light bends as it travels through space, scientists hope to uncover patterns that might reveal what dark energy really is, whether it's constant, changing, or a clue to something entirely new in physics. But perhaps the most poetic interpretation of dark energy is also the simplest. It's the universe's way of keeping itself in motion. After the chaos of the Big Bang, after billions of years of gravity trying to pull everything back together, the cosmos chose expansion. It chose to keep growing, to keep evolving. Dark energy might be the pulse of that choice, the heartbeat of an infinite story still being written. In a sense, dark energy mirrors our own curiosity. Just as it pushes galaxies apart, it pushes our understanding outward, forcing us to question everything we thought we knew about space, time, and existence. It reminds us that even in a universe illuminated by science, there are still forces we can feel only through their consequences, invisible powers shaping the very fabric of reality. Somewhere beyond our telescopes, beyond the reach of light itself, dark energy continues its silent work, stretching the cosmos, deepening the mystery, and reminding us that the universe is far from finished with its secrets. You're walking down a street in a city you've never visited before. The air smells unfamiliar, the buildings are strange, yet something stops you cold, a sudden wave of recognition. That cafe on the corner, the sound of laughter spilling from the doorway, the flicker of a red sign. You've been here before. At least that's how it feels. The moment passes as quickly as it came, leaving behind a strange mix of wonder and unease. This fleeting sensation is known as déjà vu, a French term meaning already seen. It's one of the mind's most unsettling tricks. A brief illusion of familiarity that science still struggles to fully explain. Everyone experiences déjà vu at some point in their lives. Studies estimate that 60 to 80% of people report the phenomenon, most often in their teens or 20s. It can happen anywhere, at any time, during a conversation, while traveling, or even in a dreamlike state. It lasts only seconds, yet feels profound, a glitch in reality that blurs the line between memory and perception. For centuries, philosophers, psychologists, and neuroscientists have tried to understand why it happens. Is it a memory error, a neurological echo, or something stranger, a brief glimpse across the folds of time? The earliest recorded discussions of déjà vu trace back to the late 19th century. French philosopher Émile Boirac, who coined the term in 1876, described it as the sensation of falsely remembering the present. He noted that while the event itself was new, the feeling of familiarity was overwhelming. Early psychologists thought it might stem from hidden memories, fragments of past experiences resurfacing unconsciously when triggered by similar sights or sensations. But as neuroscience evolved, new theories began to emerge. Modern brain research links déjà vu to the temporal lobe, the part of the brain responsible for memory and recognition. Within it lies the hippocampus, which helps distinguish between things we've actually seen before and those we haven't. Under normal circumstances, the brain rapidly categorizes new sensory input. This is new, this is familiar. But sometimes that system misfires. For reasons still unclear, the brain momentarily processes a new experience as though it were a recalled memory, producing the eerie, instantaneous feeling that the present has already happened. This memory glitch theory is supported by research involving patients with temporal lobe epilepsy, who often experience intense déjà vu before a seizure. When scientists stimulated certain regions of their brains with mild electrical currents, subjects reported a powerful sense of familiarity with their surroundings. It's as though déjà vu might be a small, harmless echo of the same neural misfiring, the brain's recognition circuitry activating out of context. Yet that explanation, while compelling, doesn't fully capture the experience itself. Déjà vu doesn't feel like confusion or error. It feels real, complete, vivid, and emotionally charged. People often describe it as both comforting and haunting, a moment where time folds in on itself. Psychologists have proposed that déjà vu might arise when short-term and long-term memory pathways activate simultaneously. Essentially, your brain accidentally stores the present as a memory while it's still unfolding, tricking you into believing you've lived it before. Another theory, known as the dual processing hypothesis, suggests that sensory information travels along two neural routes, one for immediate perception and another for memory integration. Normally, these systems work together, but if one is delayed by even a fraction of a second, the brain interprets the lag as recognition. It's like hearing an echo of your own thoughts. Despite these explanations, there's still an element of mystery that science hasn't pinned down. For instance, déjà vu often carries emotional weight, that haunting certainty that you should remember more than you do. It's not just a trick of the eyes. It feels deeply psychological, even existential. Some researchers believe this may stem from the brain's familiarity detection system, which operates faster than conscious recall. When that system triggers without context, a kind of false alarm, we sense recognition without memory, leaving the mind scrambling to fill in the blanks. Beyond neuroscience, déjà vu has inspired countless philosophical and spiritual interpretations. In the early 20th century, mystics and metaphysical thinkers suggested it might be evidence of reincarnation, a fleeting memory from a past life resurfacing. Others viewed it as a momentary overlap between parallel universes, an accidental glimpse into an alternate timeline where the same events have already occurred. While such ideas fall outside the realm of testable science, their appeal endures, perhaps because they capture how uncanny the experience feels. Dream researchers have also noticed a curious link. Many people report déjà vu in places or situations that resemble their dreams. It's possible that we unconsciously construct scenarios in our sleep that later echo real-life experiences. When we encounter something that resembles one of those dreams, the mind registers familiarity without knowing why. In this way, déjà vu may serve as a reminder of how thin the boundary between waking and dreaming truly is. There's also a poetic side to déjà vu, the way it connects memory, identity, and time. Every instance of déjà vu is a collision of past and present, a reminder that consciousness is not linear, but layered. The sensation of having already lived a moment might be the mind's way of recognizing the patterns of existence itself, the cyclical nature of our thoughts, behaviors, and emotions. Perhaps it's not that we've literally experienced the event before, but that we've felt it before, the same emotional resonance, repeating under new circumstances. Whatever its cause, Déjà vu reminds us how fragile our perception of reality is. The brain, for all its brilliance, can be fooled by its own complexity. A fraction of a second's delay, a spark in the wrong place, and suddenly we're standing between two timelines, one real, one imagined. For a moment, time feels like a circle rather than a line, and we glimpse just how strange consciousness can be. It's fitting that a mystery about memory endures in memory itself. Long after the sensation fades, déjà vu lingers in our minds as a paradox, an echo with no source, a memory with no past. It leaves us wondering, if our brains can make the present feel like the past, what other illusions of time might it be capable of creating? The sensation of déjà vu isn't just about memory, it's about time itself. When we experience it, something in our minds slips. The timeline that usually flows cleanly from past to present suddenly folds, creating an illusion that we're living the same moment twice. It feels like a glitch in the code of consciousness, as though the universe briefly hesitated, then replayed a second of your life, just to see if you'd notice. To understand why déjà vu feels so powerful, we have to explore how the brain perceives time, and how fragile that perception truly is. Time, at least as we experience it, isn't absolute. Neuroscientists have discovered that our sense of the present, the continuous now, is not a single instant, but a sliding window, usually about 2 to 3 seconds long. Within that window, the brain knits together sights, sounds, and sensations into a seamless moment of awareness. If something disrupts that stitching process, like a delay between perception and memory, the illusion of continuous time falters. Déjà vu could be that split-second break, a temporal echo created by the brain's attempt to resynchronize. It's almost poetic. The mind is both camera and editor, recording experience while simultaneously replaying it to itself. But what happens when those two processes overlap? Some psychologists believe that déjà vu is the result of time misalignment in the hippocampus and neocortex, the areas that manage short-term experience and long-term storage. When signals from these regions briefly fire out of sync, the brain mistakes the present for the past. It's not that you've lived the moment before, it's that your mind has already recorded it before it's finished happening. Experiments with virtual reality and simulation show how easy it is to trick the brain's sense of sequence. In one study, participants were shown slightly delayed video feeds of their own actions. After only a few seconds, many reported sensations eerily similar to déjà vu, a feeling that what they were doing had already happened. This suggests that our sense of time is less like a clock and more like a loop of feedback, constantly rewriting itself to maintain order. When that loop briefly glitches, reality feels like it folds. But beyond neuroscience, there's also something deeply psychological, even existential, about the way déjà vu touches us. It forces us to confront how memory and consciousness intertwine. Every experience we have is filtered through our past, shaped by patterns we've lived before. Déjà vu might simply be the brain's way of acknowledging those patterns, an internal signal that something about this moment rhymes with something forgotten. It's recognition without context. This idea ties into what psychologists call cryptomnesia, the phenomenon of unknowingly recalling something from memory and mistaking it for a new experience. For example, you might hum a melody you think you've just invented, only to realize later you heard it years ago. Déjà vu could be a micro version of this, the brain retrieving a vague emotional or sensory memory from a similar past event and misattributing it to the present. You're not reliving the exact same moment. you're reliving its feeling. Philosophers have long been fascinated by this overlap between memory and time. The French phenomenologist Henri Bergson once wrote that perception and memory coexist continuously. Every new experience is instantly layered atop past ones, forming a fluid continuum. In this view, déjà vu isn't a malfunction, but a momentary awareness of how the past and present are always intertwined. It's not a glitch. It's a glimpse into the true structure of consciousness. Still, there's a scientific allure to the idea that time itself could play a role. Physicists exploring the nature of space-time often describe it as a four-dimensional fabric where all events, past, present and future, exist simultaneously. Our perception of time flowing may be nothing more than the mind's way of moving through this static landscape, one slice at a time. Déjà vu, in that sense, might be a perceptual hiccup, a moment when consciousness momentarily glimpses multiple slices at once. The multiverse hypothesis offers an even stranger angle. If parallel versions of reality exist, infinite worlds where every possible event unfolds, then perhaps déjà vu occurs when two timelines briefly align. The sensation of familiarity could be the brain's reaction to an identical moment happening elsewhere, another you walking the same street, feeling the same wind, milliseconds ahead in another strand of reality. Of course, that's pure speculation. But it captures the haunting familiarity that déjà vu evokes better than almost any experiment can. There's also a growing body of evidence connecting déjà vu to dreams and prediction. Some researchers argue that the brain constantly runs mental simulations, previews of possible futures, to help us navigate reality. When we experience a situation that resembles one of those subconscious simulations, the overlap triggers recognition. It's not that we've lived the moment before, it's that our brain predicted it. Déjà vu becomes a kind of self-fulfilling prophecy, where the future feels like memory. But perhaps the most fascinating part of déjà vu isn't its cause. It's what it reveals about us. Humans crave order, and our brains are meaning-making machines. When faced with uncertainty or anomaly, we build narratives to make sense of it. Déjà vu sits at the crossroads of those narratives, an experience that feels deeply meaningful, yet defies explanation. It's a reminder that our reality is not as solid as we think. The mind, in its infinite complexity, is capable of simulating worlds within worlds, memories that never happened, moments that fold upon themselves, time that loops without warning. In the end, déjà vu may never have a single explanation, because it belongs to the delicate balance between science and mystery. It's the mind's whisper that reality is subjective, stitched together from fragments of perception, memory, and imagination. When that stitching slips, even for a heartbeat, we're left standing in two moments at once, the now and the not quite now. It's a fleeting illusion, yes, but also a beautiful one. Proof that beneath the ordinary rhythm of consciousness lies something far stranger and more fluid than we can measure. In that half-second when familiarity overwhelms reason, we glimpse the mind's greatest trick, its ability to make time itself feel like memory. And then, as quickly as it began, the moment passes, the loop closes, the hum of reality resumes its steady flow, and all that remains is the faint, fading echo of something that almost made sense. In a remote stretch of the Atlantic Ocean, where compasses spin without warning and aircraft vanish without a trace, lies one of the world's most enduring enigmas, the Bermuda Triangle. For more than a century, this region has captured the imagination of sailors, pilots, and storytellers alike. Bordered roughly by Miami, Bermuda, and Puerto Rico, The triangle covers over 500,000 square miles of open sea, a place so vast and unpredictable that it's earned the nickname the Devil's Triangle. Here, ships disappear in calm weather, instruments fail for no reason, and distress calls end mid-sentence, as though swallowed by the deep. The mystery gained worldwide attention after a series of unexplained disappearances, the most famous of which occurred on December 5, 1945. That day, 5 U.S. Navy bombers known as Flight 19 set out on a routine training mission from Fort Lauderdale, Florida. The weather was clear, the pilots experienced, and the planes in perfect condition. But hours later, radio transmissions from the squadron began to sound increasingly desperate. The flight leader, Lieutenant Charles Taylor, reported that his compasses were malfunctioning. He couldn't tell which way was west, and his surroundings didn't match his charts. "Everything looks wrong," he said over the radio. Moments later, the transmissions stopped. The Navy immediately launched a massive search operation. A rescue plane sent to find Flight 19 vanished as well, along with its 13 crew members. Despite weeks of searching, neither the aircraft nor any debris were ever found. The official report listed the cause as unknown newspapers ran with the story, and the legend of the Bermuda Triangle was born. Over the decades, dozens of other disappearances followed. Ships like the USS Cyclops, which vanished in 1918 with 309 crew members aboard, and the SS Marine Sulphur Queen, lost without a trace in 1963. Aircraft, too, seemed to vanish into thin air. The Star Tiger and Star Ariel, British passenger planes that disappeared in 1948 and 1949, both within the Triangle's boundaries. Each story followed the same eerie pattern: clear weather, sudden communication loss, and no wreckage ever found. Naturally, people began to look for patterns and explanations. Some pointed to natural causes. The region is notorious for sudden storms, strong ocean currents, and massive waves known as rogue waves, capable of engulfing even large ships. Others noted that the Bermuda Triangle lies in one of the busiest flight corridors and shipping lanes in the world. Statistically, more traffic means more accidents. Yet even accounting for that, the number of vanishings seemed disproportionately high. In the 1970s, scientists began exploring another possible culprit: methane hydrates, frozen gas trapped beneath the seafloor. If these gases suddenly erupted, they could reduce the water's density, causing ships to lose buoyancy and sink instantly, leaving little or no debris. Such eruptions might also create explosive bursts of gas that interfere with aircraft engines. It's a plausible explanation, though one that can't account for every case. Magnetic anomalies have also been blamed. The Bermuda Triangle is one of the few places on Earth where true north and magnetic north align, a condition called agonic line. This could, in theory, cause compass confusion for unprepared pilots or navigators. Some have suggested the area may also experience localized electromagnetic disturbances, subtle but powerful enough to disrupt navigation and communication systems. Pilots have reported sudden compass spins, instrument failure, and radar blips that seem to move on their own. Of course, not all theories are so scientific. Over time, the Bermuda Triangle has become a magnet for speculation and myth. Some claim it's the site of extraterrestrial activity, a hotspot where alien craft emerge from underwater bases hidden in the ocean's depths. Others link it to the lost city of Atlantis, proposing that remnants of advanced Atlantean technology still emit powerful energy fields. A few even suggest it's a dimensional gateway, a tear in the fabric of space-time through which ships and planes slip into parallel worlds. While these theories make for captivating storytelling, none have ever been supported by verifiable evidence. The most credible researchers, including scientists at the U.S. National Oceanic and Atmospheric Administration (NOAA), emphasize that most disappearances can be explained by weather, human error, and navigational challenges. They note that statistically, the Bermuda Triangle is no more dangerous than any other heavily traveled region of the ocean. Still, there's no denying the triangle's psychological hold on us. Even seasoned sailors admit to feeling uneasy when crossing those waters, describing a strange tension in the air, the sensation of being watched, or of nature itself holding its breath. Many have reported sudden drops in temperature, compasses swinging wildly, or radios filling with bursts of static that vanish as quickly as they appear. Part of the allure lies in how the Bermuda Triangle straddles the line between the known and the unknown. It's a place where science meets legend, where rational explanations coexist with whispers of the supernatural. Whether the disappearances are due to natural forces, magnetic anomalies, or simply human imagination, the triangle remains a mirror for our deepest curiosities and fears. Because what the Bermuda Triangle really represents isn't a physical danger. It's the vastness of the unknown itself. The ocean, after all, still hides more secrets than the stars. Beneath those turquoise waves, where light fades and pressure rises, entire worlds exist that we've barely begun to explore. So when ships vanish and planes go silent, it's not just a mystery of coordinates or compass bearings. It's a reminder of how fragile our presence is in a universe that doesn't owe us explanations. The Bermuda Triangle is a story we keep telling because it reminds us that even in the modern age, with satellites and science, there are still corners of the Earth and of our own minds that remain beautifully, terrifyingly unexplained. For all its legends, disappearances, and whispered curses, the Bermuda Triangle may be one of the most misunderstood regions on the planet. Its reputation as a portal of doom is built as much on psychology and coincidence as it is on science. And yet, even after decades of research, the question remains: why do so many strange things seem to happen here? Let's begin with the geography. The triangle sits in a dynamic region of the Atlantic where 5 major ocean currents converge, the most dominant being the Gulf Stream, a massive, fast-moving river of warm water that flows from the Gulf of Mexico into the North Atlantic. The Gulf Stream can reach speeds of up to 5 miles per hour, creating unpredictable turbulence, sudden whirlpools, and violent weather changes. To a ship or small aircraft, these conditions can be catastrophic. A vessel caught in the wrong current could be pushed hundreds of miles off course, while its wreckage, if it sinks, would scatter quickly, leaving no trace. Then there's the weather. The Bermuda Triangle lies within a corridor notorious for tropical storms and hurricanes, where heat, humidity, and atmospheric instability collide. Sudden squalls can form out of clear skies, producing downdrafts strong enough to pull an aircraft into the sea. These microbursts were virtually unknown until the 1980s, when radar technology finally revealed how frequently they occur. Many so-called disappearances in the triangle predate that discovery, meaning pilots may have been caught in powerful downdrafts without understanding what was happening. Some scientists believe the most plausible natural explanation lies beneath the water itself, methane hydrate eruptions. Beneath the ocean floor lie deposits of frozen methane gas, locked in crystalline structures under immense pressure. If seismic activity or temperature shifts cause these hydrates to destabilize, the gas can erupt violently to the surface. When that happens, the water's density drops dramatically. Any ship floating above could lose buoyancy and sink within seconds. Methane can also reduce air density, potentially stalling aircraft engines if released in large enough quantities. While this phenomenon has been observed in controlled experiments, its occurrence in the Bermuda Triangle remains unproven. Another compelling theory involves magnetic anomalies. Compasses are designed to align with the Earth's magnetic field, which normally varies depending on location. But in a few rare regions, magnetic north and true north align perfectly, a phenomenon called the agonic line. The Bermuda Triangle sits near this shifting line, meaning that a compass reading there can easily mislead navigators unfamiliar with magnetic variation. During the age before GPS, a small miscalculation of a few degrees could send aircraft or ships miles off course, a deadly mistake in a region with few landmarks and rapidly changing weather. But beyond these physical explanations, some of the Bermuda Triangle's mystery lies in how humans perceive coincidence and pattern. In 1975, researcher Lawrence Kusher, a librarian and pilot, conducted one of the most exhaustive investigations ever done on the subject. He meticulously reviewed every reported disappearance, combing through weather records, flight plans, and Coast Guard reports. His findings were striking. Most of the incidents attributed to the Triangle either occurred outside its boundaries, had plausible explanations like storms or navigation errors, or were exaggerated by journalists and authors. In short, the Bermuda Triangle's reputation may have been born less from physics and more from myth-making. The legend, however, owes much of its life to popular culture. In 1950, writer Edward Van Winkle Jones published an article in the Miami Herald about ships vanishing mysteriously in the region. 2 years later, George X. Sand expanded the idea in Fate magazine, calling the area a sea of mystery. But it was Charles Berlitz's 1974 bestseller, The Bermuda Triangle, that cemented the myth in the public imagination. Berlitz's book mixed genuine disappearances with speculation about Atlantis, UFOs, and time warps, captivating readers but frustrating scientists. When skeptics pointed out inconsistencies, Berlitz famously responded, "The lack of explanation is the explanation." Still, even skeptics admit that the Triangle's mystique endures for a reason. It sits at the intersection of science and wonder, a symbol of how easily our instruments and our understanding can fail us. The human mind is drawn to patterns, especially in chaos. When ships vanish or aircraft crash without survivors, we look for meaning, even if the answer lies in randomness, error, or bad luck. There's also a psychological component known as selective perception. We remember the disappearances, not the countless safe voyages that occur daily through the same waters. Thousands of ships and planes cross the Triangle every year without incident, including major commercial airlines and cruise lines. Statistically, it's no more dangerous than any other heavily traveled region of ocean. But the myth persists because it speaks to something deeper, a primal fear of the unknown, amplified by the vastness of the sea. And yet, some mysteries still linger. For example, fragments of Flight 19 have never been definitively found, even with modern sonar mapping. Some ships have been discovered miles from their last known positions, their crews missing, their instruments strangely damaged. Are these coincidences, or evidence that something genuinely strange happens here? Something we don't yet understand. In 2016, scientists from the Arctic University of Norway discovered enormous underwater craters near the Barents Sea, caused by methane explosions under the seafloor. These findings reignited theories that similar activity could occur in the Atlantic. Others point to hexagonal cloud formations identified via satellite over the Triangle, unique shapes that can produce 170 miles per hour air bombs, capable of sinking ships or flipping aircraft. It's a modern update to an ancient mystery, suggesting that nature itself might be the true culprit. So perhaps the Bermuda Triangle isn't supernatural at all, just nature at its most unpredictable. It's a crossroads of powerful weather, complex ocean dynamics, and human error, all ingredients for disaster in one of the busiest maritime corridors on Earth. But that doesn't make it any less fascinating. Because in the end, the Bermuda Triangle isn't just a location, it's a symbol. It represents the enduring space between what we know and what we don't. Whether through compasses spinning wildly or minds seeking meaning, the triangle stands as a reminder that even in our age of science and satellite precision, mystery still has room to exist. Perhaps the real secret of the Bermuda Triangle lies not beneath the waves, but within us, in our relentless need to find patterns in chaos, and our quiet awe at the realization that sometimes the world doesn't need to make sense to be beautiful. Picture this. A patient suffering from chronic pain is given a small white pill. It's explained as a new, powerful medication. Within hours, the pain fades. Days later, the patient reports feeling energetic, optimistic, and healthier than ever. There's only one twist. The pill contained nothing but sugar, no active ingredients, no medicine at all. What happened wasn't chemistry, it was belief. This is the placebo effect, one of the most remarkable and mysterious phenomena in modern science, where the mind itself becomes the medicine. The placebo effect challenges our understanding of how healing works. In clinical studies, patients who receive fake treatments, sugar pills, saline injections, even sham surgeries, often report real improvements in their symptoms. Pain eases, depression lifts. The body behaves as if it's healing, even though the treatment should have no physiological effect. It's a mystery that sits at the crossroads of psychology, neuroscience, and biology, blurring the boundary between mind and matter. The term placebo comes from the Latin phrase, "I shall please." It first appeared in the 18th century medical literature when doctors used inert substances to comfort patients for whom no treatment existed. But it wasn't until the mid-20th century that scientists began to realize how profound the placebo effect truly was. During World War II, anesthesiologist Henry Beecher observed that wounded soldiers who received saline injections instead of morphine still reported significant pain relief, simply because they believed they were being treated. That observation led to one of the most famous papers in medical history, Beecher's The Powerful Placebo, 1955. Which proposed that up to one-third of medical outcomes could be attributed to psychological factors rather than drugs. At first, skeptics dismissed the idea as anecdotal or exaggerated. But as brain imaging technology advanced, something extraordinary emerged. Modern neuroscience confirmed that the placebo effect isn't all in the head, it's physiologically real. When someone believes they're receiving treatment, the brain releases natural chemicals like endorphins and dopamine, which can reduce pain, lift mood, and even influence the immune system. Functional MRI scans show measurable changes in brain activity during placebo responses, particularly in regions associated with expectation, emotion, and self-awareness. In essence, the brain becomes its own pharmacy. Expectation triggers biology. The act of believing initiates real, measurable change. One striking example came from a 2002 study on patients with severe knee pain. Half underwent genuine arthroscopic surgery. The others received a sham operation where surgeons merely made incisions and simulated the procedure without repairing anything. 2 years later, both groups reported equal improvement in pain and mobility. The illusion of treatment had been as powerful as the surgery itself. But the placebo effect doesn't stop at pain or mood disorders. It's been observed in conditions ranging from Parkinson's disease to irritable bowel syndrome. In Parkinson's, for instance, researchers found that patients who believed they were receiving a dopamine-boosting drug showed actual increases in dopamine levels, measurable changes visible in PET scans. Similarly, in depression trials, patients taking sugar pills often experience mood improvements nearly identical to those on real medication, especially when the expectation of benefit is strong. The placebo effect also reveals a fascinating interplay between mindset, ritual, and trust. The color, shape, and even branding of a pill can influence its perceived effectiveness. Red pills are often associated with energy, blue with calmness. Injections and capsules tend to work better than tablets, and treatments administered by confident, caring doctors produce stronger effects than those given by detached or rushed ones. In short, healing is not just about molecules, it's about meaning. And yet, for every placebo, there's a dark twin, the nocebo effect. Just as positive expectation can heal, negative belief can harm. Patients who expect side effects are far more likely to experience them, even from inert substances. In one study, people told that a harmless pill would cause nausea began to feel sick within minutes. This phenomenon underscores how powerful suggestion can be, both for better and for worse. Philosophically, the placebo effect forces us to confront uncomfortable questions. If belief can produce real biological change, where does that leave our definition of real medicine? Should doctors harness the placebo response deliberately, or would that cross ethical lines? Some experts argue that open-label placebos, where patients are told they're receiving an inactive substance, but are also informed of its potential psychological benefits, could offer a middle ground. Surprisingly, even when people know they're taking a placebo, they often still experience improvement. This suggests that the healing power of the placebo lies not in deception, but in hope, the brain's ability to translate expectation into physiology. When we believe we can get better, the brain adjusts accordingly. In a sense, the placebo effect is proof that the mind doesn't just interpret reality, it creates it. Yet, despite decades of research, science still can't fully explain why some people are more responsive to placebos than others. Personality traits, genetics, and cultural background all seem to play a role. For instance, individuals with higher optimism or suggestibility often show stronger placebo responses. Certain genetic variations linked to dopamine and serotonin regulation may also enhance susceptibility. Even cultural factors matter. In societies with greater trust in medicine and authority, placebo effects tend to be stronger. In recent years, researchers have begun exploring how the placebo effect can be intentionally integrated into healthcare, not as deception, but as a way to amplify genuine treatments. Some hospitals now train doctors in therapeutic communication, using empathy, tone, and reassurance to activate the body's natural healing pathways. It's a recognition that medicine isn't just a science, it's an art grounded in human connection. But beyond medicine, the placebo effect reveals something profound about human nature itself. It shows that perception, belief, and biology are inseparable, that what we think and what we feel can literally alter what we experience. In a world obsessed with data and measurable outcomes, the placebo effect is a quiet reminder that faith, hope, and trust still hold measurable power. Maybe that's the real magic of the placebo, Not that it tricks the body, but that it proves how deeply intertwined our consciousness is with our health. We are, in many ways, self-healing organisms, equipped with an inner pharmacy waiting for the right signal. Sometimes that signal is a doctor's reassurance, a familiar ritual, or a simple pill. But often it's just the whisper of belief that healing is possible. Because, in the end, the placebo effect isn't about fooling the body. It's about revealing what the body already knows, that sometimes believing is the first step to becoming whole. Belief is a strange force, invisible, immeasurable in weight, yet capable of rewriting the rules of biology. When you expect something to happen, your brain begins to prepare for it, altering chemistry, perception, and even cellular function. The placebo effect isn't merely a medical curiosity. It's evidence that expectation itself is one of the most powerful forces in human experience. The boundary between thought and body is thinner than we ever imagined. At its core, the placebo effect reveals how anticipation shapes physiology. When a person believes a treatment will work, the brain activates regions responsible for reward, motivation, and pain control. Neurotransmitters like dopamine and endorphins surge, calming the nervous system and producing real sensations of relief. These biological responses mirror those triggered by genuine medication. To the brain, belief and biochemistry are not opposites, they are partners. One of the clearest examples of this interplay comes from experiments on pain management. Researchers have found that when subjects receive a placebo but believe it's a strong painkiller, the body releases natural opioids that bind to the same receptors targeted by morphine. When those receptors are blocked by a drug called naloxone, the placebo's effect vanishes, proving that the brain's chemistry changes in direct response to expectation. In essence, your thoughts can summon the same biological response as a pharmaceutical. Expectation also influences how we experience time and sensation. In one study, participants who believed a cream would cause itching or heat on their skin reported discomfort even though the cream was inert. Brain scans revealed activation in the sensory cortex, the area that processes touch and temperature. The experience wasn't imagined, it was physically encoded. This demonstrates that the placebo effect doesn't just alter how we feel about symptoms, it alters the reality of those symptoms. But this power cuts both ways. The nocebo effect, the placebo's shadow twin, occurs when negative expectations create negative outcomes. Patients warned of possible side effects often experience them even when receiving harmless treatments. Headaches, fatigue, nausea, all triggered by suggestion alone. One dramatic example occurred in a 2007 study where a patient attempted suicide by overdosing on experimental antidepressants. His blood pressure plummeted and he nearly died, until doctors revealed he had been given placebos during a clinical trial. Within minutes, his vitals returned to normal. His belief had almost killed him. This dual nature, healing and harm, highlights how intimately mind and meaning intertwine. Every culture on Earth has rituals of healing that rely on belief. Shamans invoking spirits, monks chanting prayers, doctors prescribing pills. The methods differ, but the underlying mechanism is universal, the activation of expectation. The brain anticipates relief, and the body follows. The setting, the symbols, the authority of the healer, all serve to amplify the signal. Modern medicine is beginning to recognize this. In clinical practice, the placebo response is not an obstacle to be eliminated, but a tool to be understood. Studies show that patient outcomes improve significantly when doctors express warmth, confidence, and empathy, even when the treatment itself is unchanged. Words alone can alter physiology. A reassuring tone can reduce blood pressure, lower stress hormones, and enhance immune function. In this sense, belief doesn't just heal the mind, it reprograms the body. The placebo effect also reveals an evolutionary advantage. From a survival perspective, the ability to self-heal through belief may have helped humans endure pain and stress in the absence of medicine. When early humans trusted a healer's ritual or felt protected by their tribe, their bodies likely released the same neurochemicals we see today in placebo responses. Optimism and trust, then, weren't just emotions, they were survival tools hardwired into our biology. Even open-label placebos, where patients are told they're taking an inactive substance, have been shown to work. In trials on irritable bowel syndrome, chronic pain and fatigue, participants informed that their treatment was a placebo still reported significant relief. Researchers believe this happens because the brain responds not to deception, but to the ritual of care itself, the act of being tended to, the symbolic beginning of healing. The body reacts to the context of healing as much as to the chemistry of it. This blurring of psychology and biology challenges traditional medicine's most fundamental assumptions. If a fake pill can create real change, what else can the mind influence? Can belief alter the course of disease? Can expectation extend life? While such questions remain controversial, evidence continues to grow that placebo mechanisms underlie much of human resilience, from spontaneous recovery in illness to improved outcomes in therapy, meditation, and even physical training. In 2014, scientists at Harvard conducted a study on athletes' endurance. Runners who were told they'd received oxygen-enhancing supplements, though they hadn't, performed significantly better, reporting less fatigue and faster recovery. The same principle applies to learning and confidence. When students believe they're capable, performance rises. When they doubt themselves, ability declines. The body, it seems, listens carefully to the stories we tell it. In many ways, the placebo effect exposes one of science's blind spots, the tendency to separate mind and body as if they were distinct systems. In truth, they're parts of one continuous feedback loop. The brain interprets meaning, the body responds, and those physical changes reinforce belief. Every thought leaves a trace, a ripple in the chemistry of being. Still, the mystery isn't just how belief works, it's why. Why do words, symbols, and rituals hold such profound power over biology? Some researchers suggest that evolution wired us to respond to reassurance because cooperation and trust increased survival chances. Others argue that expectation itself is a predictive mechanism, the brain's way of simulating reality before it happens. In this view, the placebo effect is not an anomaly, but a feature of consciousness, the ability to turn imagined outcomes into physical ones. That idea is both humbling and empowering. It suggests that healing begins not in laboratories, but in perception, in how we choose to interpret pain, hope, and possibility. It doesn't mean belief replaces medicine, but it reminds us that medicine works best when joined with belief. The pill and the perception complete each other. So the next time you take a treatment, feel a comforting hand on your shoulder, or hear a doctor say, "You'll be okay," remember that faith is not empty. It's a signal, a quiet instruction to your cells, your nerves, your chemistry: heal. And maybe that's the real secret of the placebo. It's not a trick of the mind, but a glimpse of its hidden potential. The power to change reality begins with the power to expect something better. Imagine standing in the middle of a thunderstorm. The sky crackles with electricity, the air hums with tension, and then, out of nowhere, a glowing sphere of light drifts silently toward you. It's the size of a grapefruit, maybe a basketball, flickering with bluish fire. It moves unnaturally slow, weaving through the air like it has a mind of its own. Then, just as suddenly, it vanishes. Sometimes silently, sometimes with a deafening explosion. That eerie orb is known as ball lightning, one of nature's most elusive and least understood phenomena. For centuries, witnesses have described glowing balls appearing during or after lightning storms, floating above the ground or even inside buildings. These luminous orbs seem to defy the rules of physics, passing through windows, hovering for seconds or minutes, and sometimes leaving behind the scent of sulfur or ozone. Scientists have documented reports from across the world: Russian villages, rural China, the American Midwest, even aircraft cockpits at 30,000 feet. Yet despite thousands of sightings, no one has ever fully explained what ball lightning really is. The earliest recorded reference dates back to the 1600s, when a priest in England described a great ball of fire rolling through a church, shattering windows and killing several parishioners. Centuries later, in 1753, the Russian scientist Georg Richman attempted to study lightning by replicating Benjamin Franklin's kite experiment. But when a glowing sphere appeared and struck him, he was killed instantly. Ball lightning entered folklore as something both divine and deadly, a mysterious fire no science could contain. For most of modern history, scientists doubted it existed at all. Because the phenomenon was unpredictable and rarely photographed, many dismissed eyewitness accounts as illusions, tricks of the eye caused by after-images from lightning flashes. But that skepticism changed in the 20th century, when credible witnesses, including military pilots and meteorologists, began documenting consistent patterns. During the Second World War, Allied airmen reported glowing spheres tailing their aircraft, which they nicknamed Foo Fighters. Initially feared to be enemy weapons, these lights performed impossible maneuvers and then vanished, behavior eerily similar to ball lightning. So what could cause it? Modern theories are as varied as the sightings themselves. One of the most enduring explanations is the vaporized silicon model proposed in the early 2000s by physicist John Abrahamson. According to his theory, when a lightning bolt strikes the ground, it vaporizes silica-rich soil into a plasma cloud. As the silicon oxidizes, it emits a soft glow, forming a floating, self-sustaining orb that drifts for several seconds before burning out. Experiments have successfully recreated similar glowing spheres in laboratories by vaporizing silicon under controlled conditions. Another theory points to microwave radiation. In 2012, researchers at Zhejiang University in China created ball-like plasma structures using powerful microwaves trapped inside a chamber. The electromagnetic energy formed a rotating sphere of ionized air, bright, stable, and eerily reminiscent of natural ball lightning. Some scientists now suspect that when regular lightning strikes the ground, it can generate intense microwaves that become trapped in a bubble of ionized plasma, creating a luminous ball that hovers briefly before dissipating. There are also chemical explanations. Some scientists believe ball lightning could be a reaction between atmospheric gases and charged particles, forming temporary pockets of glowing plasma. Others suggest it's an optical illusion created by electrical discharges in the eye's retina, though this fails to explain cases where multiple people witnessed the same event simultaneously. Perhaps the most haunting reports involve indoor encounters. Witnesses describe glowing orbs drifting down chimneys, rolling across floors, or entering through closed windows, sometimes leaving scorch marks, but no structural damage. In one documented case from 1963, passengers on a Russian airliner reported a glowing sphere floating through the cabin before exiting through the tail, leaving a faint smell of ozone. No one was injured, and no physical explanation was ever found. Scientists have struggled to measure ball lightning because of its unpredictability, but a breakthrough came in 2012 when researchers in China accidentally recorded one on high-speed cameras during a thunderstorm. Spectral analysis revealed the orb contained elements like silicon, iron, and calcium, consistent with the vaporized silicon hypothesis. It lasted about 1.6 seconds and measured roughly 5 meters across. For the first time, there was solid evidence that ball lightning wasn't just legend, it was a real physical phenomenon. And yet, mysteries remain. Ball lightning sometimes behaves as if it's intelligent, moving around obstacles, hovering near humans, even changing direction mid-air. Of course, there's no reason to think it's conscious. More likely, it's responding to electric or magnetic fields. But that eerie sense of awareness is what gives ball lightning its ghostly reputation. Some cultures view it as a spirit or omen, the souls of the dead wandering the skies. In Australian Aboriginal folklore, it's called Min Min lights, said to follow travellers through the desert. In Europe, medieval villagers believed it was St. Elmo's fire, a supernatural sign of divine presence or impending doom. Even now, ball lightning continues to defy prediction. It appears rarely, unpredictably, and almost never in the same way twice. Some orbs last less than a second, others persist for over a minute. Some explode with a deafening bang, others fade silently. The energy output varies wildly, from the brightness of a candle to that of a lightning strike. Despite hundreds of attempts, no one has yet found a way to replicate it perfectly in a lab. What makes ball lightning so compelling isn't just the physics, it's the symbolism, it's nature breaking its own rules, a moment where the atmosphere itself seems alive. It's a reminder that even in an age of satellites, supercomputers, and global surveillance, the natural world still holds secrets that science can barely touch. In a way, ball lightning is a perfect metaphor for mystery itself. Bright, fleeting, untouchable. We can analyze it, photograph it, name it, and still not understand it. It's a spark of chaos in a world that pretends to be orderly, and maybe that's why it fascinates us so deeply. Because every time a glowing orb drifts across a stormy sky, we're reminded that the universe still keeps a few tricks hidden, not to frighten us, but to humble us. The next time you find yourself caught in a thunderstorm, listen to the rumble of the clouds and the electric hum in the air. Somewhere, perhaps just beyond your field of vision, a flicker of impossible light might be forming. A sphere of mystery glowing softly against the laws of physics, daring you to believe what you see. Diagrams that seemed scientific, yet fantastical. Who and why? The Voynich manuscript appears to follow a structure. The first section, known as the herbal section, shows hundreds of plant drawings, each labelled in Voynichese. The astronomical section follows, containing zodiac wheels, sunbursts, and strange star charts. Then comes the biological section, where nude female figures appear in interconnected tubes and pools, perhaps an attempt to map anatomy or fertility. The pharmaceutical section depicts jars and roots, while the recipes section contains paragraphs marked with stars, as though listing instructions. Each part feels purposeful, like pieces of an encoded encyclopedia from another civilization. Over the years, theories have piled up like sediment. Some believe the manuscript was written by an alchemist or herbalist who invented a private language to hide their knowledge. Others think it's a cipher, concealing a forgotten medieval secret. There are theories linking it to Leonardo da Vinci's notebooks, to ancient Hebrew, to Chinese dialects, even to alien contact. Still others insist it's a hoax, a meaningless text designed to fool wealthy collectors, painstakingly created to look meaningful. But if it were a hoax, it's an extraordinarily complex one. Linguists analyzing the text's structure found that it follows Zipf's law, a mathematical pattern shared by all natural languages, meaning that some words appear frequently while others are rare. Even nonsense doesn't follow this rule. The Voynich text behaves like a real language with syntax, repetition, and rhythm. Someone, it seems, wasn't trying to deceive. They were writing something real. Artificial intelligence has been enlisted to help. In 2018, a Canadian research team trained an AI on hundreds of languages, then fed it the manuscript. The algorithm guessed that the text was based on Hebrew, written in a complex cipher. Translated fragments produced phrases that almost made sense, references to herbs, priests, and women, but nothing consistent. Other computer models have proposed Latin, Turkish, or a hybrid language, yet none have solved the whole. Each attempt feels like tuning a radio that catches a faint signal, only to lose it again. Some researchers propose a psychological explanation, that the author may have experienced glossolalia or automatic writing. Under trance-like states, some people produce text that feels meaningful but doesn't correspond to any known language. Could the Voynich manuscript be the world's oldest recorded case? Or could it be an elaborate form of invented language, like Tolkien's Elvish, a linguistic art project centuries before its time? Even the illustrations resist certainty. Botanists have tried to match the plants to real species, but most appear to be hybrids, stems of one plant, leaves of another. The constellations don't match our night sky. The diagrams resemble early biological charts, but with strange pipes and pools no anatomy could explain. The book feels like a fusion of science, art, and mysticism, a window into a worldview that doesn't fit any known culture. And yet, there's something undeniably deliberate about it. Each page flows with confident penmanship, as if the writer knew exactly what they were recording. Every diagram feels intentional. Whoever made it wasn't guessing, they were documenting. But documenting what? That unanswered question is what keeps the manuscript alive in our imagination. In a world that prides itself on decoding everything, genomes, galaxies, and algorithms, the Voynich manuscript remains one of the few things science cannot fully explain. It's a reminder that knowledge has edges, and beyond those edges lies wonder. Maybe it isn't meant to be solved. Maybe its creator wanted to leave behind a mirror, one that reflects our eternal hunger for meaning. Because the truth is, the Voynich manuscript tells us as much about ourselves as it does about the past. Our urge to find patterns, to make sense of symbols, to believe that somewhere within chaos there's a code waiting to be cracked. And so, it rests in its glass case, silent but alive, the most unreadable book in the world. A message from a mind long vanished, written in an alphabet we were never meant to understand. Proof, perhaps, that even in a universe governed by logic, mystery still speaks. If there's one mystery that challenges everything we think we know about reality, it's quantum entanglement, a phenomenon so strange that even Albert Einstein called it spooky action at a distance. It's a phrase that captures both awe and frustration because entanglement defies logic, defies distance, and even defies time. It's the invisible thread that binds particles across the universe, allowing one to instantaneously affect another, no matter how far apart they are. It sounds like science fiction, but it's one of the most experimentally verified facts in all of physics. To understand it, we first need to step into the world of the quantum, the realm of the unimaginably small, where the rules of classical physics collapse. In this microscopic universe, particles like electrons and photons don't behave like tiny billiard balls. Instead, they exist in superposition, meaning they can occupy multiple states at once. An electron isn't just here or there, it's both, existing as a probability wave until someone or something observes it. The moment we measure it, the wave collapses and the particle chooses a state. This simple act, observation, becomes a creative force. Reality, it seems, waits for us to look. Now imagine two particles that are entangled, their properties linked so completely that the state of one instantly determines the state of the other, even if they're separated by light years. If you measure one particle and find it spinning clockwise, the other, no matter how distant, will instantly spin counterclockwise. No signal passes between them, no force bridges the gap. They just know. Einstein refused to accept this. To him, it implied that information was traveling faster than light, breaking one of the universe's fundamental speed limits. He called it spooky action and insisted there must be hidden variables, unseen factors that explained the correlation. But in the 1960s, physicist John Bell designed an experiment to test Einstein's idea. His work, known as Bell's theorem, mathematically proved that if entanglement were an illusion, the results of certain measurements would follow predictable patterns. When scientists performed the tests, the results didn't fit the pattern. The universe, it seemed, really was spooky. Subsequent experiments in the 1970s, 1980s, and beyond confirmed Bell's predictions. The behavior of entangled particles violated local realism, the principle that objects exist independently and are influenced only by their surroundings. Instead, the data showed that the universe operates non-locally, meaning that distant events can be instantly connected, as if space itself were an illusion. In other words, reality is more deeply woven together than we ever imagined. This discovery revolutionized physics. Entanglement isn't just a curiosity, it's the backbone of quantum mechanics, quantum computing, and quantum teleportation. Yes, real teleportation, though not of people or ships, but of information. In 1997, physicists in Geneva successfully teleported the quantum state of one photon to another over several kilometers of optical fiber. Since then, scientists have transmitted entangled information between islands, across cities, and even between Earth and satellites in orbit. Each time, the particles behaved as though distance didn't exist. But what exactly does this mean for our understanding of reality? Some physicists interpret entanglement as evidence that the universe is holographic, that what we perceive as three-dimensional space is merely a projection of deeper, interconnected information. Others suggest that entanglement points to a hidden unity beneath all things, a cosmic network where every particle is entangled directly or indirectly with every other. The philosopher's version of this idea is ancient, that the universe is one vast, living whole. Quantum entanglement also redefines the role of the observer. In classical science, observation is passive. We watch things happen. In the quantum world, observation changes what happens. Experiments like the double-slit test demonstrate this beautifully. When electrons are fired through two slits toward a screen, they create an interference pattern, proof that each electron acts like a wave, going through both slits at once. But the moment scientists measure which slit an electron passes through, the interference disappears. the wave collapses and the electron behaves like a particle again. Simply observing it changes its nature. So the question arises, does reality exist when we're not looking? The implications are dizzying. Some physicists, like John Wheeler, propose that observation doesn't just affect the present, it can even affect the past. His delayed choice experiments suggest that a particle's behavior can be determined retroactively, as if the universe decides what happened only when we observe it. The observer, in this view, isn't just a witness. They're a participant in creation. If this sounds philosophical, that's because it is. Quantum entanglement forces science and philosophy to meet. It blurs the line between objective and subjective, between the physical and the metaphysical. The universe no longer looks like a collection of separate things, but a web of relationships, a cosmic dance of probabilities that becomes reality only when consciousness enters the equation. Modern technology is already harnessing this mystery. Quantum computers use entanglement to perform calculations far faster than classical machines. Instead of bits that represent either 0 or 1, quantum bits, or qubits, can exist as both simultaneously. When entangled, they share information instantly, allowing entire systems to compute complex problems at unimaginable speed. The world's leading tech companies and governments are racing to build stable quantum computers, seeing in them the power to revolutionize encryption, medicine, and artificial intelligence. Meanwhile, quantum cryptography uses entanglement to create unbreakable communication systems. Because observing a quantum system changes it, any attempt to intercept entangled information instantly reveals itself. In 2017, Chinese scientists successfully transmitted entangled photons between a satellite and Earth, achieving secure communication across thousands of kilometers. The technology, once confined to theory, now exists. A glimpse of a future where physics itself guarantees privacy. Yet beneath all the applications lies something more profound. A quiet reminder that reality is not as solid as it appears. Entanglement shows that everything, from subatomic particles to galaxies, may be part of a single, interconnected field. The universe, in this sense, isn't built from isolated pieces, but from relationships, like notes in a cosmic symphony. Einstein, who once mocked the idea, might have been unknowingly pointing to something deeper. The spooky action he resisted may not be an exception to the laws of nature, but the very fabric of nature itself, a sign that distance and separation are illusions created by limited perception. In a way, entanglement is the universe's quiet confession. Everything is connected. The particle in your fingertip might in some way be linked to another particle on the edge of a distant galaxy. They vibrate in unison, whispering across space not with light or sound, but with something more fundamental, a shared existence. Maybe that's the true message hidden in the math, that we too are entangled with each other, with the stars, with the vast invisible web that holds reality together. Science calls it quantum physics. Poets might call it unity. But both are describing the same truth. Beneath the surface, nothing in the universe is truly alone.